Welcome to our first video on NumPy lecture series. This is gonna be an introductory video. So let's get started. So what is NumPy? NumPy is a library for the Python programming language. It stands for Numerical Python. It was created by Travis Oliphant in 2005. It supports large multidimensional arrays and mathematical functions to operate on these arrays. Now, the million-dollar question is, why use NumPy when we are able to process arrays with the help of Python lists? This is because Python lists do serve the purpose of arrays, but they are too slow to process. NumPy aims to provide an array object that is more faster than traditional Python lists. Arrays are very frequently used in data science, where speed and resources are very important. If we have a slow array, then it will affect the speed of the program and also increase the time in which the program is executed. Some of you must be wondering, what is data science? Data science is the branch of computer science that deals with storing, using, and analyzing data and deriving information from it. Now, let's move on to our next question. Why are NumPy arrays faster than lists? Let us look at the basic definition of an array. An array is a collection of homogeneous data types that are stored in contiguous memory locations. This is the definition that we are learning since kindergarten. So we all know that arrays are implemented with the help of lists in Python. Now, a Python list is a collection of data types stored in non-contiguous locations. So fetching elements from non-contiguous location takes more time. This is the reason why Python lists are slower and NumPy arrays are about 50 times faster than Python lists. Now, let's look at the other benefits of NumPy. It supports efficient manipulations and operations on high-level mathematical functions and multidimensional arrays. It contains functions related to linear algebra, random number capabilities. See, random number is very important in NumPy for creating random distribution plots. We will get into it later on. It also supports functions related to Fourier transforms or transformations. It provides tools for integrating C and C++ code, etc. in Python, and NumPy is used mostly for scientific computing. Now, let's move forward to the actual coding part. First of all, let me teach you how to install NumPy on your system. Here I'm using a MacBook and I have my pip installer package already installed. So I'm just going to write pip install NumPy and hit enter button. So I have NumPy already installed on my system, so it's showing requirement already satisfied. But in your system, it will process for some time and download the essential modules. Now, let me just get started with Python on 3 and hit enter button. Now, I need to import NumPy. So for that, I'm going to write import NumPy as np and hit enter. Now we don't get an output here. This is because there is nothing to display or there's no such command. Now I'm going to create an array, arr equal to np dot array, and I'm going to pass a Python list, that is 1 2 3 4 5. So I have passed a list. You can give any values, that doesn't matter. Now I've successfully created an array. Now I want to print this array. For that I need to write print bracket arr and hit enter. So we have successfully created and displayed an array. Now some of you must be wondering, why did we import numpy or numpy as np? Now let's see if we import it directly without giving it a nickname or a pseudonym. So I'll just go back to Python 3, type Python 3 and hit enter. And now I'll import numpy by writing import numpy, hitting enter, and then creating an array again, that is arr or array name equals to numpy dot array and passing a Python list to it. So now I'm gonna print this array by writing print bracket arr and hit enter. Now you can do this way or you can do it the other way. It doesn't matter, but in large programs you may need a pseudonym or a nickname or a reference, so that while writing large fragments of code you can reduce. Hello, welcome back to our course on NumPy. Today we are gonna learn about n-dimensional arrays. So let's get started. So our first and foremost question is, what is ND array? So according to numpy.org, an ND array is a usually fixed sized, multi-dimensional container of items of the same type and size. The number of dimensions and items in an array is defined by its shape, which is a tuple of n non-negative integers that specify the sizes of each dimension. The type of items in the array is specified by a separate data type object called as dtype, one of which is associated with each ND array. So this is more of a complicated definition. So in simpler words, we know that numpy is mostly used to work with arrays. The array object is numpy is called as ND array. We create a numpy ND array object by using the array function. So the thing is, ND array is nothing but just n-dimensional array, like 1 dimension, 2 dimension, 3 dimension. Let me just type Python 3 and hit enter. Now I'm going to import numpy. So import numpy as np and hit enter. Now I'm going to create an array, that is arr or array name np dot array, and we are going to pass a Python list. Here I'm taking the values 1 2 3, but you can take any value you want to. So I have created an array. I have passed a Python list. Now I'm going to print it. So I'm going to write print array name or arr. And now I'm going to hit enter. So I got my array. Now let us print the type of array. So I have told you earlier that array object in numpy is ND array. Now let's verify it by printing the type. So print type and array name. So we can see that we got output as numpy dot ND array. Now Type function is a built-in Python function that tells us the type of the object passed to it. Like in previous code, it shows that ARR or array name is numpy.ndarray type. Now, some of you must be wondering, why do I always pass Python list as input? So, in general, to create an ND array, we can pass a list, tuple, or any array-like object into the array method. It will be converted to ND array. So now I'm going to show you an example where I'm going to pass a Python tuple. So life is going as usual. Let me just write import numpy as np and hit enter. Now array name is equal to numpy.array, but this time I'm going to pass a tuple. So now I'm going to print. So you can see that it is in a list format. But when I print the type and pass array name, it shows numpy.ndarray. Now let's talk more about arrays. So generally we have an n-dimensional array where n can take the values 0, 1, 2, 3 up to n. So let's start with zero-dimensional arrays. So zero-dimensional arrays are nothing but scalars. For example, the numbers 1, 2, 3, 4, each of them represent a scalar or a zero-dimensional array. Now, an array that has zero-dimensional arrays as its elements is called as a unidimensional or 1D array. For example, I write bracket and inside I give the values 1, 2, 3, 4. So one-dimensional array has zero-dimensional arrays as its elements. Similarly, a two-dimensional array has one-dimensional arrays as its elements. A three-dimensional array has 2D arrays or matrices as its elements. And n-dimensional arrays have n minus one-dimensional arrays as its elements. So two-dimensional arrays are called as second-order tensors. Three-dimensional arrays are called as third-order tensors, and generally an n-dimensional array is called as nth-order tensor. But the most basic and most common arrays that we use in our daily life are one-dimensional arrays. Higher dimensional arrays find more relevance in fields such as machine learning and artificial intelligence. Now, let's implement these arrays. So guys, I have opened my terminal. Now, I'm just going to type Python 3 and hit enter. I'm going to import numpy as np, hit enter, and then I'm going to write arr0 is equal to np.array in bracket. This time I'm not going to pass a list, I'm going to pass a scalar because this is a zero-dimensional array. Now I'm going to print arr 0 and hit enter. So I got the result as 21. Note that this is a scalar and not in list, or we can say it is not in list format. Now I'm going to create a one-dimensional array. arr1 is equal to numpy or np.array, and this time I'm going to pass a list. Now I'm going to hit enter. So array has been created. Now I'm going to print it. So I'm going to write print arr1, close the bracket and hit enter. Now let's move on to a 2D array. So I'm going to write ARR 2 is equal to np dot array. Please note that this time I'm going to pass one-dimensional arrays as its element. So I'm to go write square bracket again, and 1 2 3 4. Sorry, you can take anything, 1 to 5 and comma, and I have to pass one more list because basically its elements are one-dimensional arrays. Now let me just hit enter and print the two-dimensional array. Sorry, I have to print ARR of 2, not the value at index 2. So please take care. You can also make this mistake. So now I've printed the array successfully. So let us now create a three-dimensional array, which is third order tensor. So ARR of 3 is equal to np dot array, and this time we are going to pass two-dimensional arrays as its elements. So square bracket, and one more square bracket, and pass the elements. So I have passed one 2D array. Now I'm going to pass one more. So this three-dimensional array has two-dimensional arrays as its elements. So 3D array has been created. Now we have to print it by using print, and in bracket we have to write ARR of 3 and hit enter. So we have successfully printed a 3D array. Now we have seen how to create a one-dimensional array, a two-dimensional array, and a three-dimensional array. Now I'm giving you an assignment. Create a four-dimensional array. You have to follow the same procedure. You just need to pass 3D arrays as its elements. In today's lecture, we covered n-dimensional arrays, nd array, use of type function, one-dimensional array, zero-dimensional array, two-dimensional array, three-dimensional array, how to create them, and we have also given you an assignment. That's all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates, and stay tuned for next lecture. Bye. Hi guys, welcome back to our course on NumPy. In our last lecture, we covered n-dimensional arrays, and today we are gonna learn about array indexing. So let's get started. So the first question that arises in our mind is, what is array indexing? So array indexing is nothing but accessing an array element. Now, how can we access an array element? The answer is pretty simple, by referring to its index number. Indexes start from 0. The first element is stored at the index 0. the second element is stored at index 1, and so on. That nth element is stored as index n minus 1. Now let's see how can we do indexing in arrays of different dimension. So let's first access array element for a 1D array. So we just simply need to write print array name, and we have to write the index, that is a. In 2D array it will be print a comma b, because we have two parameters, row and column. Similarly, in a 3D array, which is a third order tensor, we need to pass three parameters. And in general, in an ND array or n dimensional array, we have to pass n parameters as array index to print or access the element. Now let's move on to the coding part. So I have opened my terminal. Let me just write Python 3 and hit enter. Now import NumPy as np, hit enter. And now I'm gonna create a 1D array. So let's start with 1D array. So ARR or array name 1 is equal to np dot array, and I'm gonna pass a Python list to it. So let it be 2 comma 3 comma 1 comma 5 comma 3 comma 2 comma 6 and hit enter. So we have successfully created a 1D array. Now let's print an element or access an element. So I'm gonna access the element at index 0, but I made an error. Instead of passing ARR1, I passed ARR, which is not defined. So I'm gonna do it again. Print ARR1 of 0 and the last element ARR1 6. So element at first index is 2 and the element at sixth index is 6. So I can also perform algebraic operations while printing. Let me just show you. So I'm gonna write print ARR1 index 5 into ARR1 and index, let it be 2. So it will show the multiplication of elements as these two index. So element at index 5 is 2 and element at index 2 is 1. Should it display the result 2? Similarly, we can perform subtraction. So ARR1 element at index 3 minus element at index 1. Sorry, I made an error again. Let me just correct it. So the answer is 2. So let's move on to a 2D array. Let me just create a 2D array. So I'm gonna write ARR2 is equal to np.array, and this time I'm gonna pass one D array as its elements. So let it be 1 comma 2 comma 3 dot comma 4 bracket close, 5 comma 6 comma 7 comma 8 bracket close. So I'm gonna print the second element in second row So guys, am I doing it right? I have done it wrong. Please try to be careful because this is the wrong index. I want to access some other element, but I have passed some other index. Now, this index 0, comma 1, it represents the first, the second element in first row and not the second element in second row. So please be careful because you can also do these kind of mistakes, and I'm trying to help you rectify those mistakes. So the element that I have actually printed was it was the first element. No, it was not the first element. It was the second element in first row. So guys, please try to be careful. This is the most common mistake that we do while indexing. I'm showing you this because I have seen a lot of people making these kind of mistakes even in engineering second year and third year. This is a very common mistake, so please try to be more careful and write the indexes correctly. So second element in second row, so I'm gonna pass 1 this time, and it is 6. Now should we move on to a 3D array? Let's move on to a 3D array. So I'm just gonna create a 3D array. Come on guys, I'm just joking. I'm not gonna create a 3D array. Instead, I'm gonna give you an assignment, that is create a 3D array yourself. We have discussed how to create a 3D array, and now you have to create a 3D array and access the first element in 3D array. So in today's lecture, we covered array indexing, indexing in 1D array, indexing in 2D array, and I also gave you an assignment to do indexing in a 3D array. That's all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe for updates, and stay tuned with us for more lectures. Bye. Hi guys, welcome back to our course on NumPy. In our last lecture, we covered array indexing, and today we are gonna learn about negative indexing and the use of ndim method. So let's get started. So first of all, what is negative indexing? So in negative indexing, we use negative indexes to access array elements from the end. Let's take an example that we need to print or access the last element of the second row in the given array. So index number for elements for second row will be like 1, comma n minus 1 when we are using positive indexing, and where we want to access the nth element from the beginning. But in case of negative indexing, the index number for the second row will be like 1, comma minus n, where we want to access the nth element from the last. Now please note the difference. In positive indexing, we are accessing nth element from the beginning and we are giving the value 1 comma n minus 1. But here we want to access the nth element from the last. So we are giving the values 1 comma minus n. Now let's do negative indexing for this array. So here by positive indexing, the index of the last element of second row will be 1 comma 4 as it is the fifth element from the beginning, and in general for nth element from the beginning the index number will be row count minus 1 comma n minus 1. And if we do negative indexing, the index will be 1 comma minus 1 as it is the first element from the last or the nth element from the last. So in general, for nth element from the last, the index number will be row count minus 1 comma minus n. Now so let's move on to the code part. Let me just write Python 3 and hit enter. Now import NumPy as np, hit enter. Let's create a 2D array first. So I'm gonna create a 2D array. So I'm gonna write arr2 is equal to np dot array. And now since we know that the elements of a 2D array are 1D array, so I'm gonna pass 2 lists as its element. So let the list element will be 1 2 3 4 and 2 4 3 1. Close the brackets and hit enter. So we have successfully created a 2D array. Now let's print. So I'm gonna write print the second element, the second row and the last element so it's gonna be arr or array name 1 comma minus 1. Because positive indexes start from 0 and negative indexes start from minus 1. So the second row and last element is 1. Now let's print the array. So we have printed the array and you can see that the second row and last element is 1. Now some of you might be wondering, can we pass both the values in negative indexes? Yes, we can. So for the last row, it will be minus 1 and for the last element, it will be minus 1. So second row and last element when we have passed both the values as negative is same. It's 1. Now let's print the second row and the second last element. So I have written the command and now I'm gonna hit enter. So as you can see that the second row and the second last element is 3. Now let's do it again by changing the row value. Now we are gonna print the first row and the second last element. So I've written the command and hit enter. So the result is 2. as you can see from the array. Now I'm gonna do it again, but this time I'm gonna give negative values. So the result is again 2. This was all about negative array indexing. So now I'm gonna give you an assignment, that is create a 1D array and access its last element. Now, yeah, you have to use positive indexing as well as negative indexing while doing this assignment. So now let's move on to our next topic for today, that is use of ndim method. So ndim method returns the number of dimensions in an array. The syntax is print bracket array name dot ndim, or first we can store the result in a or any variable, like a is equal to array name dot ndim, and then we can print a. So let's see an example. So I've opened my terminal. I'm gonna write Python 3 and hit enter. I'm gonna import NumPy as np, hit enter. Now I'm gonna create arrays. So first array is ARR0 is equal to np.array bracket. I have passed the value 32, and this is a 0-dimensional array or a scalar. Now I'm gonna create a 1D array. So now I'm gonna create a 2D array. So I've created a 2D array. Now let's move on to the use of ndim method. So I'm just gonna write print ARR0 dot ndim. So it's gonna give me 0 because it's a 0D array. Similarly, to check the dimension of the 1D array, I'm gonna write ARR1 dot ndim. So it shows result 1. And in the same way, when we do it for 2D array, it's gonna print the result as 2. So by the use of ndim method, you can get the dimension for any array. It will display the result as the number of dimensions present in that particular array. Now the assignment for you is to print the number of dimension for the 4-dimensional array that you created as the part of your previous assignment. So this was all about the use of ndim function or ndim method. Hi guys, welcome back to our course on NumPy. Today we are gonna cover array slicing. So let's get started. So first of all, What is array slicing? Slicing means taking elements from one given index to another index. Here, instead of passing an array index, we pass a slice. So the syntax is that we pass a starting element and an ending element that is denoted by start and end respectively. We can also define the number of steps we want to take while slicing. So we can pass either two parameters, start and end, or we can pass three parameters that are start, end, and the step. So now the question arises, what if I ignore or don't pass these three parameters? If we don't pass start, it is taken as 0. If we don't pass end, it is taken as the length of array in that dimension. And if we don't pass step, it is taken 1 by default. Now, we can also slice the array using negative indexes. So this is a brief introduction to array slicing. Now let's move on to the coding part. So guys, let me just import NumPy as np and hit enter. Now I'm gonna write array name or arr is equal to np.array, and now I'm gonna pass a Python list to it. Let it be 1 comma 2 comma 3 comma 5 and hit enter. Now let's slice elements from index 1 to index 5. Sorry, here we have indexes from 0 to 4, that is size minus 1. So if I pass so we are gonna slice elements from index 1 to index 4, and I'm gonna write print array name arr, and I'm gonna give start as 1 and end as 4, that is the last index, and I'm gonna press enter. So it displayed 2, 3 and 4. So there's a very important observation to make here. So what is that observation? We can observe that it has included the value or the element at index 1, but it has not included the element at index 4. So it's not gonna include the value at index 4. So indexing will always neglect the element which is present at end or the parameter that is given. So in general, when we write array start colon n, it will ignore the element at the ending index, and it's gonna include the element at the start index. So please keep this in mind, because in questions related to output we can make this kind of silly mistake, so it's good to be careful. So start will be included in the result while end won't be included in the result. Now let's see what happens when we don't pass start. So I'm gonna write print arr. So array has been printed. Now I'm gonna give it a slice. So I'm gonna print arr. I'm not gonna pass start this time. So start is empty, and I'm gonna give int as the third index. So it should print 1, 2, and 3. As you can see, the result is 1, 2, and 3. Now, let's see what happens when we don't pass end. So let me just write print array name or arr, and I'm gonna pass start as 2, and I'm not gonna pass any end. Let me just hit enter. So at second index the value is 3, and since we have not passed an end, it will take the size of array in that dimension, that is 5, as end. So it's gonna print 3, 4, and 5 minus 1, the value at fourth index. So it print 3, 4, and 5. So here in above examples we did not pass the step size, so by default it is taken as 1, as we already discussed. Now let's do or let's pass step size. I'm gonna create a new array, that is arr1 is equal to np.array, and I'm gonna pass a list of a bigger size. The current list was short in size, so if I increase the step size there will be less elements. So to exhibit or to display the method of slicing using step size, I have created a new array and I've printed the existing array as well as the newly created array. Now let's pass step size and do the slicing. So for the first array, I'm gonna give the start as 0, and I'm gonna give end as 4, and let the step size be equal to 2. So the value at 0th index is 1 and at 4th index is 5. So it should print the elements 1 and 3. Sorry, there was a mistake in the syntax. So it shows the invalid index, or sorry, invalid syntax. So let me just rectify it and do it again. So this time I'm gonna write print arr and print arr1 again, and let me just write the command again. So I'm gonna write arr 0, 4, and 2. So the result is 1 and 3. Now let's do it for the second array. So the start was 0 and the end was 8. So it displayed 1, 3, 5, and 7 as theoretically expected. Now we have an observation to make here. if we observe carefully the commands that we have written have returned every other element from index 0 to 4, from the index 0 to 4 for the first array, and every other element from index 0 to 8 in the second array. So now let's move on and print every other element in the whole array. So let's see how to return or print every other element in the whole array or entire array. So I'm gonna write print array name. I'm not gonna pass the start or end. I'm just gonna pass step size, that is 2. I'm gonna close the bracket and hit enter. So it has returned every other element in entire array. Now similarly, return every other element in the second array. So it shows 1, 3, 5, 7, and 9. So we have returned every other element in the array. Now let's slice a 2D array. So I'm gonna write arr2 equal to np dot array, and I'm gonna pass two 1D arrays as its elements. Let them be 1, 2, 3, 4, and the other 1D array will be 1, 5, 6, 7, and 8. Sorry, there's mistake in parenthesis, so let me just do it again. I've created a 2D array. Now let me print it. So I've printed the array. Now I'm gonna slice. So I'm gonna slice element or elements from index 1 to index 4, and of course the index 4 will not be included, and in second row. So I'm gonna write print arr or array name, and I'm gonna give, please be careful here, we have to pass the first row, and instead of column value we are gonna pass the slice. So please be careful. So I've passed, sorry, there was a mistake. Let me just correct it and hit enter. Sorry, the array name was written incorrectly. So let me just change it to arr2. So it has given us the corresponding values that are 6 and 7. Now similarly, we can pass the row value as a slice and give some column value, or we can do both, pass the row value as a slice or the column value as a slice. So similarly, we can slice a 3D array, and in general, we can slice an n-dimensional array. So there's an assignment for you. Create and slice a 3D array. Now, some of you must be wondering that can we slice an array using negative indexes or with negative indexes? The answer is we can do it for sure. So surely we can. So I'm just gonna print the existing array, and now I'm gonna slice it using negative indexes. So first of all, we need the values of the indexes to slice. So let's slice from index -3 to index -1. So let me just write the command, that is print arr -3 comma -1. Sorry, I need to pass the slice instead of these values. So this kind of mistake is very common. Please be careful because you have to pass the slice and not the index. So I have passed a slice and it has shown me the result 8 and. Hi guys, welcome back to our course on NumPy. In today's lecture, we are going to study the data types in NumPy. So let's get started. Let's first take a look at the default data types in Python. They're integer, float, boolean, string, and complex. Integer represents numbers like 1, 2, 3, -1, -2, -3. Float represents real numbers. Boolean represents true or false value, and string represents text. While complex represents complex number which has real as well as imaginary part. Let's move on to data types in NumPy. NumPy has some additional data types and they're represented using alphabets. Lowercase I stands for integer, lowercase u stands for unsigned integer, lowercase b stands for boolean, lowercase f stands for float, lowercase c stands for complex float, lowercase m stands for time delta, uppercase m stands for date time, o stands for object, uppercase s represents string, and v represents chunk of memory or void. Now let's move forward to another topic, that is how to check the data type of an array. So NumPy array object has a property called dtype that returns the type of array. The syntax is print, and in bracket we have to give array name dot dtype, and this command or this line or this thing will return us the data type of the array that we have passed. Now let's move on to the coding part and implement this. So I have opened my terminal and I'll write Python 3 and hit enter. Now I'm gonna import NumPy as np and create an array. Arr is equal to np.array, and now I'm gonna pass a list to it. But this time the list contains string characters and not integers. So let the elements be pen, banana, you can take anything, or chalk. So close the brackets and hit enter. Now I've created an array. Now we are gonna print the data type. So I'm gonna write print, and in brackets I'm gonna write array name or arr dot dtype and hit enter. So I have obtained the result as U6. Please note that here U stands for Unicode string. So now let's take one more example. Now I'm gonna create one more array, and it's gonna be an array of integers. So arr1 is equal to np.array, and now I'm gonna pass an integer list to it. So let the elements be 1, 2, 3, 4, close brackets and hit enter. Now I'm gonna print arr1 dot dtype. So the result is int 64. Please note that int refers to integer, so data type is integer 64. Now let's move on and see how can we create an array with a specified data type. So to create an array with a specified data type, we need to pass an optional argument while creating the array, that is dtype. So the syntax is going to be array name is equals to np.array, and we have to pass list, and we have to add a comma, and we have to pass data type as the required data type. Now let's take an example. So let me just zoom the terminal. Now I'm gonna write Python 3, hit enter, import NumPy as np, hit enter. Now I'm gonna create an array, but this time I'm going to specify the data type. So let's create an array with data type 4-byte integer. So I'm gonna write arr or array name is equals to np.array, and this time we are going to pass a list, but we are also gonna specify the data type. So I have to specify the data type as int, or in this case we can use I also, or I4, so 4 bytes, and I hit enter. So I'm gonna print array, and I'm going to print its data type. So print arr dot dtype. So you can see it's int 32. So 4 bytes means 32 bits. Now let's take one more example. So let's create an array with dtype or data type string. So I'm gonna write arr1, or whatever the array name is equal to np.array, and I'm gonna pass a list to it, but this time I'm gonna specify the d type or data type as s, that represents string. I made an error, there's some problem in brackets. I have added an extra right bracket, so let me just rectify it. So let me just print the array. Print arr. I have to print the arr1. So print arr1. Hit enter and you can see the result as a list of strings. And when we print the d type or data type, it shows S1. That is string and 1 byte. So now let's see what happens when a data type cannot be converted. When you have a mixed kind of list, that is, it contains integers, alphabets, or it's in a mixed form, and there's problem in conversion. So let me just give an example. Array2 is equal to np.array, and I'm gonna pass a character in list and other elements as integers. And I'm gonna specify the data type as I, that represents int. So it says unmatched. So there's some problem in brackets. Let me just correct it and do it again. So it shows invalid literal for int with base 10. So this is the problem that arises when a data type cannot be converted. Hi guys, welcome back to our course on NumPy. In our last lecture, we covered data types and how to create an array with a specified data type. So today we are going to cover the asType method. So let's get started. So we know how to create an array with a specified data type. Now the question arises, how to convert data type on existing arrays? The answer is, the best way to change the data type of an existing array is to make a copy of the array with the asType method. The asType method returns a new data frame where the data type has been changed to a specified data type. Or in simpler words, we can say that asType function creates a copy of the array and allows you to specify the data type as the parameter. Please note that we can specify the data type using short notations like I for integer, f for float, or by using the data types directly like int for integer, float for float, etc. Now let's see an example. So let's change the data type from float to integer by using I parameter value. So let me just write Python 3, hit enter. I'm gonna import NumPy as np. Now I'm going to create an array. So I'm gonna write np.array and I'm gonna pass a list. So this is a list of floating point numbers. So it gave me an error because I made a mistake. I need to insert a comma. So let me hit enter. I've created an array. Now let me use the asType method to create a new array. So new array name is equal to arr dot asType, and in bracket I'm gonna specify the data type. So it's I here and new array has been created. Now let's display. So I'm gonna write print arr, hit enter. So this was our original array. Let's display the data type of the existing array or the old array. It's showing float 64. Now let's print the new array and print the data type of the new array. So I'm gonna write print new dot nditer. So it's showing int32. Now let's move on to next example. Change data type from float to integer by using int parameter value. So last time we used I. This time we are going to use int. So I'm gonna write Python 3 and hit enter. I'm gonna import NumPy. I'm gonna import NumPy as np. Now I'm gonna create an array. So arr or array name is equal to np.array, and I'm gonna pass a list to it, a list of floating point numbers. I made a mistake. I need to go back to rectify it, and I have to add brackets. So I passed the list and I have created an array. Now let's create a new array using asType method. So new equal to array name dot asType, and I'm going to specify the data type as int. Last time we used I in commas. So I'm gonna print array, and I'm gonna print the data type of original array. So it's float 64, and I'm gonna print the new array and its data type. So the result is int64. Let's move on to another example. Change data type from integer to boolean. Now if the data is, or the data element is 0, it will return false, and if it is greater than 0, it will return 1 or true. So I'm gonna import NumPy again as np. And hit enter. Now I'm gonna create an array of integers. So I'm gonna write np.array, and I'm gonna pass a list to it. And don't forget to add brackets. So now I'm gonna hit enter. Array has been created. Now let's print the array and print its data type. So it's int64. Now let me print, now let me create a new array using asType method. So new equal to arr.asType, and in type I'm going to specify boolean. So it's bool or bool for boolean. So the new array is true, false, true, false, true. These are boolean values. So I'm gonna print the data type of the new array as well. So it is bool or boolean. So in today's lecture, we covered the use of asType method, and we looked at. Hi guys, welcome back to our course on NumPy. In our last lecture, we covered the asType method in NumPy, and today we are gonna learn about the difference between copy and view in NumPy. So let's get started. So it is copy versus view. So copy creates a new array. It's a new array. And view is just a view of the original array. Don't worry, you'll understand it when we get into the code. Copy owns the data and view does not own the data. Those who have read database management system, they might be acquainted with the term view. So the changes made to copy will not affect the original array, but the changes made to view will affect the original array. So copy is just a new array, which is a copy of the present array. And view is just the same array with different name. The changes made to view will affect the original array. Now let's move on to the code. I've opened my terminal. Now I'm gonna write Python 3 and hit enter. Now I'm gonna import NumPy as np and hit enter. Now I'm gonna create an array with array name arr is equal to np.array, and I'm gonna pass a Python list. Hit enter. Now array has been created successfully. So now I'm gonna write x is equal to arr or array name dot view and brackets and hit enter. So I've created a view. Now I'm gonna print the original array as well as I'm gonna print the view. So print x. So they both are the same. Now let's observe what happens. Or let's now make changes to original array and see whether they are reflected to view. So arr 0 is equal to 34. Now we have initialized the 0th index as 34. Now I'm gonna print array as well as view to observe the difference. See, the array has been updated and the view has been updated. So the changes in original array can affect view. So we can see that view is affected by the changes made to the original array. Now let's move forward and make a copy. So now I'm going to create a copy. So y or copy name So copy name or y is equal to arr dot copy, and now I'm gonna write brackets and hit enter. Now a copy has been created. Now let's print the copy. So it is same as the array. Now let's see what happens if we make changes in original array and their corresponding changes to copy and view. So let's make changes one more time. So I'm gonna write arr or array name and initialize the second index as 243. So I've made changes to original array. Now let's see whether these changes are reflected to view and copy. So now I'm gonna print view. See, it has been updated. Now let's see what happens to the copy. Now we can observe that we have made changes to the original array and our view, which is denoted by x, has been updated or affected by the changes made in original array. But the copy remains the same. It has not been updated. So the copy y is not affected by changes while view x is affected. Now let's move on to our next topic, that is how to check if array owns its data. So this is basically a method of checking whether a given element is a copy or it's a view. So we know that copies owns data and view does not own data. But how to check this? So every NumPy array has an attribute base that returns none if the array owns the data. Otherwise, the base attribute returns the original object. Now let's take an example and understand it through a code. So I'm gonna write Python 3 and hit enter. Now I am gonna import NumPy as np. Now I'm gonna create an array. ARR is equal to np.array and pass a list to it. So I've created an array. Now I'm gonna create a view as well as a copy. So for view, x is equal to array name.view or arr.view, and for copy, y is equal to array name.copy or arr.copy. Now let's use base. So I'm gonna write print x dot base. So it returns the original array because this is a view. X is a view, so it returns the original array, while y returns none because it's a copy. So x dot base returns us the original array because it's a view. Hi guys, welcome back to our course on NumPy. In our last lecture, we covered the difference between copy and view. And today we are gonna learn about the array shape. So let's get started. So the first question is, what is array shape in NumPy? So the shape of array represents the number of elements present in each dimension. Now the next question arises in our mind is how to get the shape of an array. So we can use the array attribute called shape to get the shape of an array. So the result is a tuple which each index having the number of respective elements. Now let's move on to the code. So let me just write Python 3 and hit enter. Now I'm gonna import NumPy as np and hit enter. So now let's start with a zero dimensional array. A zero dimensional array is a scalar. So I'm gonna write arr0 or array name is equal to np.array, and in bracket I'm gonna write a scalar. This time I'm not gonna pass a tuple. So now I'm gonna print arr0. Sorry, I need to rectify it. arr0 and hit enter. So I got the scalar as result. Now I'm gonna print arr0 dot shape. So it returns me an empty tuple. So it doesn't have any dimension. So it is a 0D array. So now let's move on to 1D array. So I'm gonna create a 1D array first. So array name arr1 is equal to np.array, and this time I'm gonna pass a tuple. So the values from 1 to 9 constitute the tuple. Now I'm gonna print the array and I'm gonna print its shape. Since it is a 1D array, it has one dimension and the number of elements in that dimension is 9. So now let's move on to a two-dimensional array. So first I'm going to create a 2D array. So arr of 2 or array name is equal to np.array. This time I'm gonna pass two 1D arrays because we know that in a 2D array or matrix the elements are 1D arrays. So I've passed the elements. Now let me print arr2 and now I'm gonna print its shape. So print arr2 dot shape. So it has two dimension. The number of elements in first dimension are 2 and in second dimension are 4. It is other way of saying that number of rows are 2 and number of columns are 4. Now moving on to a 3D array. Let's create a 3D array. So the elements of a 3D array are 2D arrays. So we have to create a 3D array accordingly. So I've created a 3D array. Now I'm gonna print array and I'm gonna print the shape of the array. So print arr3 dot shape. So it's showing me list object has no attribute shape. So let me just do it again. There's an error. So it's an attribute error. So let me just create a 3D array again. So let's try again. This is the basic thing. When you fail, you have to try again. Just don't give up. So arr3, let's name it arr3 new. arr3 new. So arr3 new is equal to np.array, and now I'm gonna pass 2D arrays. So I've created a 3D array, a new 3D array from scratch again, and now I'm gonna print arr3 new dot shape. Now I'm gonna hit enter. So this has 3 dimension and the number of elements in respective dimension are 2, 2 and 3. So this is the optimized or the exact or the correct output. Now I have got an assignment for you. You have to create a 4D array and you have to print the shape of that 4D array. You can also create a 4D array using ndim method as we discussed. So in today's lecture, we covered array shape. Hi guys, welcome back to our course on NumPy. In our last video, we covered shape of a NumPy array. And today we are gonna learn about the use of reshape method. So let's get started. So reshaping NumPy arrays. So we know that shape of an array is the number of elements present in each dimension. So reshaping refers to changing the shape of an array. So what is actually achieved by reshaping? That is addition or removal of dimension and changing the number of elements in each dimension. So let's move on to the code. Let me just write Python 3 and hit enter. Now I'm gonna write import numpy as np and gonna hit enter. Now reshape from 1D to 2D. So we have to change the shape of an array from one dimension to two dimension. So I'm gonna write, firstly we have to create an array to use the reshape method. So I'm gonna create an array. So array name is equal to numpy or np.array, and I have to pass a list. So this is a list of 12 elements. So I'm gonna close the bracket and hit enter. So I've created a 1D array. Now I have to convert the 1D array to, I have to convert the 1D array with 12 elements into a 2D array. So I'm gonna write new array or new array name is equal to current array name arr dot reshape. I'm gonna specify the parameters. So into array we have two parameters, that is row count and column count. So now I'm gonna print the current array as well as the new array. So you can see that I got a new array with 4 rows and 3 columns. So we have 4 rows with 3 elements each, or we can say that we have a new 2D array with 4 rows and 3 columns. So let's reshape from 1D to 3D. So we are going to reshape from 1D array to a 3D array or 3-dimensional array. So I'm gonna write new array name is equal to current array name or arr dot reshape, and I have to specify 3 parameters here. So let them be 2, 3 and 2 so that the product is 12. So now I'm gonna print the current array as well as the new array. So you can see the result. We have a 3D array with 2 elements, and each element is a 2D array consisting of 3 rows and 2 columns. Now we have an important observation to make here. Do you guys observe anything? Yes, there's a very important observation here. So the product of the parameters that we have passed and the elements in the number of elements that we have is same. So the product of parameters is equal to the number of elements in 1D array or in general. So this is a very important thing. So we have to take care of this thing in our mind while reshaping the arrays. Now the question is, can we reshape into any shape? So the answer is no, we can't do that. So we can't reshape into any shape that we want to. There are some constraints. So let's see an example. So let me just create an array. So ARR or array name is equal to np.array, and I'm gonna pass a list. So let the number of elements be 8. Now I have created an array. It has 8 elements. Now, what are the possible combinations of parameters that I can pass? So let's see. We can make a 2D array with 4 rows and 2 columns. We can make a 2D array with if we create an array with 8 rows, it's just gonna be a 1D array because the thing will remain the same. So 8 rows, and it's gonna be a skew. So let it be 2 rows and 4 columns. So we can make an array with 2 rows and 4 columns, or 4 rows and 2 columns. But we can't make a 2D array with 3 rows and 4 columns, because that would require 3 into 4, that is 12 elements. So that would require 3 multiplied by 4, that is equal to 12 elements. But we have only 8 elements. So now let me just create new arrays. So firstly, creating a 2D array with 4 rows and 2 columns. So let the new array name be ARR new. ARR new is equal to ARR dot reshape, and I'm gonna pass 4 comma 2. Now I'm gonna print the new array. Sorry, the name is ARR new. So let me hit enter. So we got a new array with 4 rows and 2 columns. Now let's make a 2D array with 2 rows and 4 columns. So I'm gonna write ARR new is equal to ARR dot reshape 2 comma 4. I'm gonna print the new array. So we have got a new array that is 2-dimensional with 2 rows and 4 columns. Now let's try to create a 2D array with 3 rows and 4 columns. So this time I'm gonna pass 3 comma 4. So sorry, I passed 3 comma 3, but still it cannot reshape because the size 8 can't be reshaped into size 9. So it gives an error. Hi guys, welcome back to our course on NumPy. In last video, we started the reshape method, and today we are gonna continue it. So let's get started. Now let's see whether reshape method returns a copy or it returns a view. Let me open my terminal. So I'm gonna import NumPy as np. I'm gonna hit enter. Now let me create an array. So array name is equal to np.array, and I'm gonna pass a list to it as usual. I'm gonna hit enter. So array has been created. I'm gonna print array name or ARR dot reshape. I'm gonna give the parameters, and I'm gonna add an attribute base to it, which is used to check whether it's a copy or it's a view. So it gave me an error because the array cannot be converted because size is 9 and the shape is 8. So I changed it to 3 comma 3 and I have written another command print array name dot reshape and parameters are 3 and 3 and added the attribute base to it, and I got the result as the original array and not none. So since I got the result as the original array, this is a view, this is not a copy. Now you might be wondering, what if dimensions are unknown? So we are allowed to have one unknown dimension. It means that we don't have to specify an exact number for one of the dimension in reshape method. Instead, we pass -1 and NumPy calculates the dimension for us. So we know that number of elements is equal to product of the parameters. So if we have two parameters, the calculation will be number of element divided by the remaining parameters. Now let's see an example through code. So I have opened my terminal once again. I'm gonna write Python 3, hit enter, and I'm gonna import NumPy as np. So I'm gonna create an array again. So array name is equal to np dot array, and I'm gonna pass a Python list to it. So NumPy array has been created successfully. Now I'm gonna write new array name or new ARR equal to current array name or ARR dot reshape, and I'm gonna pass 2 comma 2 and -1. So this parameter will be calculated automatically. Let's see how. So I'm gonna print ARR, that is original array, and new array, that is print bracket new ARR. So this is the new array. Now I'm gonna print the shape of the new array. And hit enter after closing the brackets. Sorry, I have added an extra pair of bracket. Let me just correct it. So I'm gonna write the command again. So the answer is 2 comma 2 comma dot comma 2. So the NumPy has automatically calculated third parameter. Now let's move on to the next topic, that is flattening the arrays. So what is flattening? Flattening array means converting a multidimensional array into a 1D array. We use reshape and in bracket -1 method to do it. So the syntax is array name dot reshape and in bracket we have to pass -1. Let's see an example. So I've opened my terminal and I'm gonna import NumPy as np. Let me create a 2D array for flattening. So ARR2 is equal to np dot array, and I'm gonna pass two 1D arrays as the elements of a 2D array. So I have created a 2D array. Now I'm gonna print the array name is ARR2. So let me correct it and print the original array. And now I'm gonna print the shape of the original array. So it is 2 comma 4, that is 2 elements in first dimension and 4 elements in the second dimension. So 2 rows and 4 columns. So now I'm going to reshape it. And now I'm gonna print the new array. So you can see I've got a 1D array or a flattened array. I'm gonna print its shape as well. So you can see that the shape is 8 elements in first dimension. Hi guys, welcome back to our course on NumPy. In our last lecture, we covered reshape method, and today we are gonna cover another method under shape manipulation, that is the transpose method. So let's get started. So what is transpose? Transpose is an operator which flips a matrix over its diagonal. It switches the row and the column indexes of the matrix, thereby producing another matrix. Some of you must be acquainted with the transpose method. So let's see an example. So let me just write Python 3, hit enter. Now I'm gonna import NumPy as np and hit enter. So let's create a 2D or two-dimensional array first to find its transpose. So let the array name be arr2, and arr2 or array name is equal to numpy.array, and I'm gonna pass two 1D arrays as elements of a 2D array. Sorry, I made a mistake. I have imported numpy as np, so I need to correct it. So please take care of the name and the pseudonym or alias. So I've created a 2D array. Now I'm gonna write the command to find its transpose. So array name or arr2 will be equal to here I have to write another command, that is np.transpose, and I have to pass the array name, that is arr2. Now let me hit enter. So this is the transpose, and let me print the original array so that you can see the difference. So this is the original array, and what we printed previously was the transpose. So we can see that original array and its transpose can be obtained by interchanging the rows and columns in a 2D matrix. Now let's move on to another question. This is a mixed problem. On reshape method and transpose, first we need to create a 1D array, then we need to reshape it to a 2D array, and then we need to find the transpose of the two-dimensional array. So let's go to the solution. Let me just write Python 3 and hit enter. Now I'm gonna import NumPy as np and hit enter. Now I'm gonna create a 1D array. So let's create a 1D array first. So let me just write array name. This time I'm taking array name as arr. So arr is equal to np.array, and I'm gonna pass a Python list to it. So let the number of elements be 8. Now let's reshape this 1D array or this array to a 2D array. So I'm gonna write x is equal to arr dot reshape or array name dot reshape, and I'm gonna pass the parameters, that is the number of rows and the number of columns I want in my 2D array. So I've created or reshaped this into a 2D array. Now let's print the original array, the reshaped array or array after reshaping, and the transpose. And the transpose. So let me just write print ARR or print original array. And I'm gonna write ARR. So original array has been printed. Now I'm gonna print the array after reshaping. So this time it's gonna be X. So the format in which it is displayed, it's a little different. Let me just print X simply so that you can see the whole array at one place or whole matrix at one place. Now I'm gonna print the transpose. So I'm gonna write np dot transpose. So X, it's not X, it's np dot transpose, and I'm gonna pass X as a parameter. So you can see the transpose has been displayed. Now we can see the original array, the array after reshaping, and the transpose of the reshaped array. So we have fulfilled all the requirements of the question. Hi guys, welcome back to our course on NumPy. In our last lecture, we covered the transpose method under shape manipulation, and today we are gonna learn about the flat and the flatten method under shape manipulation. So let's get started. So our first question is, what is flattening? So flattening an array means converting a multidimensional array into 1D array. As earlier discussed, we can use the reshape method by passing -1 as a parameter to flatten an array, but we have other methods as well. So one of the methods is flat. This function returns a 1D iterator over the array, or in simpler words, it will return the element corresponding to the index in flattened array. And the other method is flatten method. This function returns an array collapsed into one dimension, or it returns a 1D array. Now let's see some examples. So let me just open my terminal. So let me write Python 3, hit enter. Now I'm gonna import NumPy as np and hit enter. So I have to create an array first. So let the array name be A. So A is equal to np.array. And I'm gonna create a 2D array. Because a 1D array is already flattened and the elements of a 2D array are 1D arrays. So I'm gonna pass two 1D arrays as the elements of this 2D array. So I've passed elements and hit enter. Now I'm gonna print the original array. So you can see the array has been displayed. Now let me use the flat method first. So now let's use the flat method. So print after using the flat method or the flat function. So we are going to print a dot flat and we are gonna pass an index. So this function will return us the value at index 5 in the flattened array. Now you can see the value at index 5 in the flattened array is 6. So the value at the index 5 of the flattened array is 6 and it has been displayed. So the flat function returns one iterator over the array. Now let's print the original array and the flattened array to verify our answer. So I'm gonna write print array. Sorry, I made a mistake. The array name is A. So I have to write print A. Now let me print the flattened array using reshape method first. So print A dot reshape. I'm gonna pass -1 to it. So the flattened array has been displayed and you can see that the value at the 5th index in the flattened array is 6. Now let's discuss one more way of flattening the array, that is the flatten method. So now let's look at an entire method of flattening array, or a method of flattening the entire array. There's a little error. So this is a method of flattening the entire array. So I have to write print. So let me print the original array first. So print original array. Let me just write print and pass the array name to print the original array. So the original array has been displayed. Now we have to flatten it using the flatten method. So I'm going to write print and I have to use the method or the function flatten. So I'm gonna write flattened array. And now I'm gonna write a command as a continuation of this. So a dot flatten. So flattened array has been displayed. So this flattened array is 1, 2, 3, 4, 5, 6, 7 and 8 in one dimension. So we have got our flattened array using flatten method. So in today's lecture, we covered flattening, flatten method and flat method under shape manipulation. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates. And please stay tuned with us for more lectures on this series. Hi guys, welcome back to our course on NumPy. In our last video, we covered the flat and the flatten methods under shape manipulation. And today we are gonna learn about the concatenate method. So let's get started. So the first and foremost question is, what is concatenation or concatenation? So concatenation refers to a group of things linked together or occurring together in a way that produces a particular result or effect. And in the context of programming, it refers to the operation of joining two entities. Now these entities can be arrays, strings, or anything. So here we are going to deal with concatenation of two arrays or merging of two arrays. So the general syntax for concatenation is numpy dot concatenate or concatenate, and we have to pass the list of arrays we want to merge and the corresponding axis. Now you must be wondering, what is axis? So axes, plural, are defined for arrays with more than one dimension. A two-dimensional array has two corresponding axes. The first running vertically downwards across row or the axis 0, and the second running horizontally across columns or axis 1. Likewise, a 3D array has 3 axes, a 4D array has 4 axes, and so on. So now let's move on to the code. Let me just open my terminal. So let me just write Python 3 and hit enter. Now I'm gonna import numpy as np. Hit enter. Now let's concatenate or join two one-dimensional arrays. So first of all, we are going to concatenate or merge or join two 1D arrays. So let's create two 1D arrays first. So I'm gonna write arr1 is equal to np.array, and I'm gonna pass a Python list to it. Now I'm gonna create the second array in a similar manner. So I have created two 1D arrays. Now let me print the result after concatenation of these two arrays. So I'm gonna write np.concatenate, and I'm gonna pass first array or arr1 and the second array or arr2. Close the bracket and hit enter. There was a bracket missing. I have to add an extra set of brackets. So it gave me an error. Let me just add an extra pair of brackets and hit enter. Now we can see the result after merger of these two arrays. Now we can see that these arrays have been concatenated. So we can say that the arrays have been merged, concatenated, or joined. Now let's move on and try to concatenate 2D arrays. First of all, we have to create two two-dimensional arrays. So I'm gonna write arr2 1 is equal to numpy or np.array, and I'm gonna pass two 1D arrays as elements of the two-dimensional arrays. Let me now create the second two-dimensional array in a similar manner. So let the elements be 4, 5, 6 and 7, 8, 9 for the second array. Now I've created two 1D arrays. Before concatenating 2D arrays, Let's first try to understand the concept of axis. So I'm gonna concatenate the 1D arrays again, but this time we'll have an observation to make. So I have to concatenate the 1D arrays again. So now I'm gonna print the result. See, I've concatenated the 1D arrays again. So by default, the concatenation is done along the axis 0. So by default, the concatenation is along the axis 0. So you must be wondering, why did not I pass an axis value when I concatenated these 1D arrays? Now let's try to pass the value of axis. So now let's concatenate along axis 1. So I'm gonna give the value of axis equals to 1. So it is given axis 1 is out of bounds for array of dimension 1. This is because axis 0 is only present in case of a 1D array. For axis 1, we have to move to a 2D array. Now let's concatenate our two-dimensional arrays. So I'm gonna give array 2 1 and array 2 2. I'm gonna hit enter now. Now I'm gonna print the result, or ARR new. So this is the result of concatenation of 2D arrays along the axis 0. So this can be concatenated about axis 0, 1 and none. So an array of dimension n can be concatenated along n number of axes starting from 0, 1 and so on, including none. Now I'm gonna display the result after concatenation along axis 1. So this is the result. So in today's lecture, we covered the concatenation method under shape manipulation. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates. And please stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our last video, we covered array concatenation under shape manipulation. And today we are going to learn about the sort method, which is used for sorting arrays in NumPy. So let's get started. So first of all, what is sorting? So sorting refers to the action of putting elements in an ordered sequence. An ordered sequence is any sequence. It can be numeric or alphabetical. The order can be ascending or descending. Now the question is how to sort. The NumPy ND array has a function or method called as sort that will sort a specified array. Now let's move on to the code. So let me write Python 3 and hit enter. I'm gonna import NumPy as np and hit enter. Now let's sort the array alphabetically first. So I need to create an array first for sorting purpose. So let it be arr, and the command is arr is equal to np.array, and I have to pass a Python list. So let the elements be banana, almond, or anything you like. So the third element is chocolate because I like chocolate. So I have closed the brackets and I have hit enter. So array has been created successfully. Now let's sort. So I'm gonna write print, and in bracket I'm gonna write np dot sort, and I'm going to pass the array name, that is arr, and close the brackets. So we have displayed the sorted array. So we got the result as the sorted array. Now let's move on. Let's sort a Boolean array. So Boolean values are either true or false. So we have to create a Boolean array first. So arrb or Boolean array is equal to np.array. I have made a mistake. Let me just correct it. So this time we are going to pass either true or false values. So let it be false, false, true, and close the brackets and hit enter. Now let's display the sorted array. So print np.sort, and I'm gonna pass the array name or arrb and hit enter. So I've got the sorted array. But the thing is, here the array I have passed and the sorted array appear to be the same. So we can't conclude anything because what we passed an input, we got at output. So here we got the sorted array, but it appears to be same as original array. So we can't determine whether it is sorted or not. So there's no way of determining because input is same as output. So how can we determine whether it's actually sorted or not? So let me do some changes in the Boolean array and sort it again. So I'm gonna add some true, false values randomly to the array. So I've added some values and changed the array, and I've sorted the array. So now we can see that the false values are displayed first and true values are displayed at the last. This is an important observation. So now we can observe that in a sorted Boolean array, false values will be displayed before the true values. So this is an important conclusion. Please take care because this may be asked in an output question in your examination. So let's move on to two-dimensional array. Now let's sort a two-dimensional array. So we have to create a 2D array first. So arr2 is equal to np.array, and this time we are creating a 2D array, so we have to pass two 1D arrays as its elements. So let the array elements be 3 to 1 for the first 1D array, and let it be 4, 8, 2 for the second 1D array, which is an element of 2D array. Now I'm gonna print np.sort, and I'm going to pass the array name. So I have got the result at the sorted array. Now we can observe that both the individual elements of the 2D array have been sorted. Or we can say both the 1D arrays that or which are the elements of 2D array have been sorted. So in today's lecture, we covered the sort method for sorting the arrays, and we sorted 1D array and a 2D array. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates. And please stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our last video, we covered the sorting, and today we are gonna learn about iteration. So let's get started. So first of all, what is the meaning of iteration? Iteration means going through the elements one by one. We can use the basic for loop of the Python for iteration. So iteration on a 1D array will go through each element or scalar one by one. Now let's move on to the coding part. So let me just write Python 3, hit enter. Now I'm gonna import NumPy as np, hit enter. Now iteration or iterate on the elements of a 1D array. So this is the example where we're gonna iterate a 1D array. So let me create a 1D array first. So I've created a 1D array. Now I'm gonna iterate it using for loop. So for x in array name or arr, and now I'm gonna write print x and hit enter twice. So the elements of 1D array have been displayed. So this is the result. We can see that when we will iterate on a 1D array, it will go through all elements one by one. So we can say that when we'll iterate on a 1D array, it will go through all the elements one by one, where individual elements are scalars. This is a very important observation. that we are actually going through the elements of the array. In this case, the elements are scalars, so the scalars have been displayed. Now let's iterate on 2D arrays. So we are gonna create a 2D array first. So array name or arr2 is equal to np.array, and now I'm gonna pass two 1D arrays to it because elements of a 2D array are 1D arrays. So I have passed. Now I'm gonna hit enter. So array has been created. Now I'm gonna use for x in array name or arr2, and I'm gonna print x. So you can see that two lists have been displayed and not the scalars. So some of you must be expecting the scalars as a result, but we got the answer as two lists, which are the original elements of our 2D array. So we can say that when we iterate on a 2D array, it will go through elements of 2D array. Which are not scalars. So elements of a 2D array are not scalars but 1D arrays. So in this case, 1D arrays will be displayed. So some of you might be expecting scalars, but we got a different result. Now let's move on to 3D arrays. So in similar manner, I need to create a 3D array first. So I'll write array name. Sorry, I've already imported, so I don't need to write import. So I have to write array name is equal to np.array, and this time we are gonna create a 3D array. So always remember, to create a 3D array, we have to pass 2D arrays as elements. So I've passed 2D arrays and they are 2 in number. So let me just close the brackets and hit enter. So array has been created. Now I have to write the for loop. So for x in arr or array name, and I have to print x and hit enter twice. So we can see that we got the result as 2D arrays. So we can say that when we iterate on a 3D array, it will go through all the elements. So it will go through all the elements one by one. So it will go through all the elements of a 3D array, which are 2D arrays. And not the scalars. So in this case also we got the result as the elements of 3D arrays, which are 2D arrays, and not the scalars. So there's an assignment for you. So what you have to do is you have to iterate on the 4D array that you have created as a part of your previous assignment. So we'll continue our discussion on iteration in the next lecture. So today we started with the basics of iteration in NumPy. That's all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates. And stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our last lecture, we covered the basics of iteration, and today we are gonna continue with this topic. So let's get started. So iteration down to the scalars. So to return the actual values, the scalars, we have to iterate the arrays in each dimension. Now let's see how. So let me just write Python 3, hit enter and import NumPy as NP as usual. So let's have a quick recap. So in our last video, we saw that when we iterate on, so if we iterate on a 1D array, it goes through each element or each scalar element. So it goes through each scalar element one by one. Similarly, when we iterate on a 2D array, it goes through each 1D array element one by one. So because the elements of a 2D array are 1D arrays, so it goes through each 1D array one by one. So similarly, when we iterate on a 3D array, it goes through each 2D array element so it goes through each 2D array element one by one. So we are going to generalize it. So in general, we can say that if we iterate on a or on an n-dimensional or nd array, so if we iterate on an nd array, it will go through n-1th dimensions one by one. So this is the generalized result. Now the question is, how to iterate down to the scalars. So how to iterate down to the scalars? How to achieve this thing? So we have a goal and we need to achieve it. So how to do it? So one of the many ways. So see, whenever we have a problem, we have a lot of ways of tackling it. So one of the method that we can use here is using nested loops. So we are going to use nested for loops here. So first example is iterate on each element or each scalar element of a 2D array or a two-dimensional array. So now let's create a 2D array first. So elements of a 2D array are 1D arrays. So I've passed them and hit enter. Array has been created. Now I'm going to write the for loop. So for x in array name or ARR and nested loop for y in. This time we are not going to write in ARR or array name. We are going to write in x. And we are going to write print y. Now we can see that each scalar element of the 2D array has been displayed. So we are successful in iterating down to scalars. Now let's move on to iteration down to scalars in three-dimensional arrays. So similarly, let's iterate down to scalars in a 3D array. So we have to create a 3D array first, and keep in mind that elements of an ND array are n-1D arrays. So elements of a 3D arrays are 3 minus 1 equals to 2D arrays. So we are going to pass 2D arrays as elements. So you can take any random values. Close the brackets and hit enter. So array has been created. Now we have to write the for loops or nested loops. So for x in array name or ARR, for y in x, and for z in y. And now I have to write print z in place of print y, as we did in 2D arrays. So we can see that each scalar element of 3D array has been displayed. So we are successful in iterating down to scalars in a 3D array. Now I got an assignment for you. So iterate down to scalars in the 4D array that you have created as a part of your previous assignment. So you have to iterate down to scalars in a 4D array. So in today's lecture, we covered how to iterate down to scalars in higher dimensional arrays. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates, and stay tuned with us for next lecture on this series. Thank you. Hi guys, welcome back to our course on NumPy. In our last lecture, we covered the method of iterating down to scalars in higher dimensional arrays using nested loops. And today we are going to learn about the nditer method. So let's get started. So first of all, what is nditer method? So the function nditer is a helping function. It solves the basic issues that we faced in iteration. So in basic for loops, if we have nd array or n-dimensional array, iterating through each scalar element would require n loops, which can be difficult to write for arrays with very high dimensionality. So what we are gonna do is use nditer method. So let me just write Python 3, hit enter. I'm gonna import NumPy as np. So iterate all the elements or all the scalars, or iterate down to the scalars in a 2D array. So this is an example that we are going to do using nditer method or function. So first of all, let's create a 2D array. So you know the procedure how to do it. We have done it almost 50 times or more, I guess. So create a 2D array. The elements of a 2D array are 1D arrays. So pass them, close the brackets, and hit enter. So array has been created successfully. Now I have to use one for loop with nditer method or nditer function. So for x in np.nditer, and I am going to pass the array name. So I have written the command, and now I'm going to write the print function. So print x and hit enter twice. So I got the result. as scalars. So the result is scalars, and we didn't need to use nested for loops. So we iterated down to scalars with help of one or only one for loop and one nditer function. So now the question is, why is nditer function more convenient? So you can say that why, or you can ask that why should we use nditer function rather than using nested loops? Because all of us are habitual of using nested loops while iteration. So nditer function is convenient because we don't need to use nested loops. But you might have a counter argument that you are comfortable with using nested loops, but then my response would be you can use nested loop for 3D array, 4D array, 5D array, but the array is of 1000 dimensions. Let us consider that we have an array of 1000 dimension. Then you need to write 1000 for loops to iterate down to scalars in an array of 1000 or array with 1000 dimensionality. So nditer function is convenient because we don't need to use nested loops here. So in general, if we have an nd array, we need to use n loops to iterate down to scalars. So if n is of order 100 or 1000, it will increase LOC or line of control code. It will increase the line of code and effort of the programmer. So you need to write a lot of commands or lines in your code if you want to iterate down to scalars in an array of very high dimensionality. So we can say that nditer function is more convenient. So now let's iterate down to scalars in a 3D array. So let's iterate down to scalars in a 3D array using nditer function. So the process is same. We need to create a 3D array first. So elements of a 3D array are 2D arrays. So I need to pass those. You can choose any random values that you want to choose. So just pass the parameters and close the brackets and hit enter. Now you have created a 3D array. Now we have to write for loops. So for x in np dot nditer, and we are going to pass the array name or arr. Now we are going to write print x and hit enter twice. So we got the desired result. So I can say that we are successful in iterating down to scalars in a 3D array. Now I have an assignment for you. So what you have to do is you have to iterate down to scalars in a 4D array or 4-dimensional array that you have created as a part of your previous assignment. So you have to create a 4D array and use nditer method to iterate down to scalars. Now let's move on to next topic, which is iterating with different step size using nditer method. So in last examples, we had the step size at 1. So let's change the step size and look at a different example. So the question is, iterate in a 2D array with help of nditer function and with step size 2. So I have to create the array first. So follow the standard procedure. So I've created the array. Now I have to write the function. I have to write the for loop and I have to use nditer function. So for x in np dot nditer, and I have to pass array, and in array inside the square brackets I have to pass only the step size. So it's going to be 2. I need to use square brackets. So let's close the brackets and hit enter. Oh, sorry, by mistake I used an extra closing bracket. Let me just remove it and hit the enter again. So I have written the for loop. Now to write print x. So I got the result. So we have iterated down to scalars in a 2D array with step size 2. So the result is we iterated this 2D array down to scalars with step size 2 and using nditer method. So now I have one more assignment for you. So the assignment is iterate down to scalars in the 4D array that you have created as a part of your previous assignment. And you have to change the step size to 3. So in this lecture, we studied about the use of nditer method. So that's all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates. And stay tuned with us for next lecture on NumPy. Thank you. Hi guys, welcome back to our course on NumPy. In our last lecture, we continued with our discussion on iteration in NumPy arrays, and we demonstrated the use of nditer method. Today we are going to start with searching and look at the where method. So what is searching? Searching is the action of accessing a specified element from the array. So here in this lecture, we are going to use the where method to search in a NumPy array. So let me just write Python 3, hit enter. Now I'm gonna import NumPy as np. So in this lecture, we are going to demonstrate the use of where method for searching. So let me just create an array first. So array name or arr is equal to np.array. And I'm going to pass a Python list to it. So I can write any random elements while creating the list. And I need to close the brackets and hit enter. Make sure that your parentheses are balanced. Now I'm gonna create a variable x and I'm going to store the index in it. So x is equal to np.where, and I'm gonna pass the condition. So where ARR is equal to 2. So this will return the indices where the value at index is 2. So we can see that the indexes or indices where the values 2 are 1, 6 and 8. So this means that the value 2 is present at multiple indices which are 1, 6 and 8. Now let's move on to the next example. Now we are going to search for a value which is not present in the array. So let me just give the value 10 which is not present in the array. I've stored the result and I'm gonna print it. So we can observe that I got the result as an empty set or empty list, indicating that the value 10 is not present in the array. So this results or it returns an empty list. This means that the value 10 was not found or it's not present in the array. Now let's look at some more examples. So one more example. So we have to find the indexes where the values stored or values are odd. So now we are going to write x is equal to np dot where, and we are going to pass array name or ARR mod of 2 not equal to 0. So this is the condition for the odd elements, that when they are divided by 2, the remainder is not 0. So we are going to print the original array, and now we are going to print the indexes where the values are odd. So at index 0, that is 1, at 2, that is 3, at 4, that is 5. So these are the indexes where the values are odd. Now next example is find the indices where values are even. Now we have to replicate the same thing. We just need to change the condition. For odd elements, the condition is array name mod of 2 not equal to 0. But here in case of even elements, the condition will be array name or ARR mod of 2 equal to 0. Now I have displayed the original array, and now I'll display the indexes containing even values. So the even values are present at index 1, 3, 5, 6 and 8. So in this lecture, we started with searching in NumPy arrays, and we covered or demonstrated the use of where method. That's all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we started our discussion on searching in NumPy arrays, and I demonstrated the use of where method. In today's lecture, we are going to cover the search sorted method for searching in NumPy arrays. So let's get started. So search sorted method performs binary search in an array. It returns the index at which specified value should be present in order to maintain the order. So the thing is, it assumes the array to be sorted. So let's move on to the coding part. Let me just write Python 3, hit enter. So here we are going to use search sorted method. So search sorted method performs binary search on the array. So we need a sorted array. So binary search is always performed on a sorted array. So we need a sorted array just we do in binary search. So array name is equal to, first I have to import NumPy. So import NumPy as np, hit enter. Now let's create an array in which the elements are present in ascending order, or in other words, an array which is already sorted. So let me just create an array. So array name or arr is equal to np.array, and I have to pass a sorted Python list to it. So let the elements be 1 to 10. Close the brackets and hit enter. Now let's find the index at which value 7 is present. So I have to create a variable to store the value. So it can't be arr, it has to be some other thing. So x is equal to np.search sorted, and I'm going to pass the array name and the value. So I have to print x. So the result is 6. It indicates that the value 7 is present at the index 6. Now let's search for a value that is not present in the array. So I have to write x is equal to np.search sorted. I have to pass the array name as well as, the array name is arr. So I have to change it to arr. So I've passed 12, which is not a value at the index. So I'm going to print x. So the result is 10, which is a little ambiguous because there is no index 10 and there's no value 12. Let's try one more time. So I'm going to write 130 this time, and I'm going to print x again. So again I got the result as 10, which is the number of elements present in array, and it's little ambiguous because there is no index 10. We have indexes from 1 to 9. So I think when there is a value which is not present in the array, it gives the number of elements present in the array as the result and not the index or empty list. So let's search from the right side. So in previous example, the indexes were counted from the left. Now let's count the indexes from right. Now let's create a new array, and elements are 3, 4, 5 and 6. So I'm going to write x is equal to np.search sorted. This time I'm going to pass the array name, the element to be searched, and also the side. So the side is right. So hit enter, and I'm going to print x. So the result is 2. But note that this is not the negative indexing from right, because generally we prefer to do negative indexing from right. So one thing that we need to observe is here the element is present at index 2 if we do positive indexing from right. That is, we considered 6 at 0th index, 5 at first index, and 4 at second index, and so on. Now let's search for multiple values. So till now we searched one value at a time, but now we are going to search for multiple values at once. So let's print the array first. So array is 3, 4, 5, 6, and I'm going to write x is equal to np.search sorted, and I'm going to pass the array name arr, and I'm going to pass the list of values for searching. So I've passed the list of values, and I'm going to print x. So it denotes that the values 4 and 5 are present at the indexes 1 and 2. One thing to note here is, here instead of returning a single index, it returns a list of indices corresponding to the values or the search values. Or we can say that the values entered. Now let's move on to the next example, which is in the form of a question. So the question is, for an array given as 1, 3, 2, 1, 5, 32, 53, 21, 67, we need to search the location of element or element 2 using search sorted method. So this is the question. Now let's move on to the solution. First of all, the important thing to note here is that since the array is not sorted, we have to sort it first, because if we use the search sorted method, it performs the binary search, and for the binary search we need a sorted array. So since the array is not sorted, we need to sort it after creating and then search sorted method. So these are the steps to approach the solution. So first of all, we have to create the array. So array name is x this time. So x is equal to np.array, and I have to pass the list of elements given in the question. So I've passed the list of elements and I've created the array successfully. Now, second step is to sort the array using the sort method as already discussed in previous lectures. So if you are not acquainted with it, please go through the previous lecture. Another thing to note here is that I have not sorted it. I've just displayed the result. After sorting, I have to sort and store the result. So if I don't do that and directly use the search sorted method, I will get ambiguous results or error. So let's see what if I just sort it and display the result but not actually store the sorted result. So after printing u, I get the result as 1, but 2 is present at the location 2 and 3. So the result is wrong. So the correct way to do it is I have to store the result of the sorted array. So there is a mistake here. There were no changes made to the original array. So what I have observed is many students just display the result of after sorting and they don't actually make the changes to the original array or store it in another variable. So this is a very common mistake. Please take care of this while doing any project or during your exam. So now I have stored the result in a variable y, and now I'm going to use the search sorted method again. So I'm going to print the value of u. So it returns me the index 2 because 2 is present at the index. It is the desired result. So in today's lecture, we covered the search sorted method for searching in a NumPy array. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates. And please stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we studied about the search sorted method to search in a NumPy array, and today we are going to begin our new topic, that is filtering of arrays. And this lecture will cover two methods of filtering. First one is using Boolean index list and the other one is by the use of filter function. So let's get started. So what is filtering? Getting some elements out of an existing array and creating a new array out of them is called as filtering. In NumPy, we can filter an array using Boolean index list. A Boolean list is a list of elements corresponding to indexes in the array. We can also filter an array using the filter function. If the value at the index is true, that element is contained in the filtered array, and if it is false, that element is excluded from the filtered array. Now let's move on to the code. So I'm going to write Python 3, hit enter. I'm going to import NumPy as np, hit enter. Now let us first look at what we are going to do. So filter is used to extract values from a sequence under certain conditions. So if the condition is fulfilled, the value will be extracted, and if it's not fulfilled, the value won't be extracted. So first, we are going to create a Boolean array. So let the elements be true, false, true, false. Now let's create our sequence from which we have to extract the elements. So this is a Python array consisting of Boolean values. Now let's create a NumPy sequence or NumPy array. So array name is equal to np.array. Let me pass values. So I'm gonna pass 4 values because I have 4 Boolean values in my original array. But I made a mistake. I named both the arrays as same. So I need to change one of it. So if I don't change and continue with the same names, it will give me an error. So I need to change. So I'm gonna change it. So let the boolean array's name be ARRP, denoting that it's a boolean array. Now I'm going to do the action of filtering by writing the command new denotes the filtered array is equal to array name, and in square brackets I'm gonna pass the boolean array. Now I'm gonna print the new array. So print new. So I got the result as two elements corresponding to the true values and excluding the elements corresponding to the false values. So we observe that in the above example. So the example will return 411 and 21 because the values in the array corresponding to their indexes in the boolean array were true. So only 411 and 221 were filtered because the boolean values corresponding to these elements were true. Let's look at another example now. So in this example, we'll create a filter. Now let's define a new sequence or declare a new sequence. So let it be integers from 1 to 10. So I have created a sequence. Now I'm going to use the filter method to create a filter and not use the boolean list directly. So I'm going to write list, and this time I have to pass. Sorry, I also need to write filter method. So I have made a small error. Let me just rectify my mistake. So I have made a mistake and I have to correct it. So let me just go back and write filter. So I have to create a list. So list, and in list I have to write filter, and in filter I have to pass two sequences. The lambda function will generate a sequence which will contain boolean values, and the other sequence will be our original sequence. So we got the result as 2, 4, 6, 8 and 10, and we observe that this filter which we have created filters out the even elements from the array. Now let's create a filter to filter out the odd elements from the array. So the procedure will be same. We just need to change the condition in the lambda function. Those who are not acquainted with lambda function, please refer to our Python playlist. So we just need to change the condition to not equal to 0, and we obtained the odd elements. So we have filtered out the odd elements from the given sequence. So that's how we filter array using the filter function or filter method. So we demonstrated the use of Boolean index list and filter method for filtering an array. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates. and stay tuned with us for next lecture on NumPy. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we started our discussion on filtering of NumPy arrays and we discussed two methods of filtering arrays, that is using Boolean index list and filter method. Today we are going to look at another method, that is the direct method. So let's get started. So filtering is a quite common task in NumPy. So there is an easy method to do it. We can directly substitute the array instead of the iterable variable in our condition and it works just fine. It will be clear when we look at some examples. So let's move on to the code. Let me just write Python 3 and hit enter. Now I'm gonna import NumPy as np and hit enter. Now let's create a filter directly. So creating filter directly from the array. That's what we are gonna do. So to create a filter, we need an array first. So let's create an array first to filter out the values from the array. So we have to write array name or ARR or array or whatever you want. I'm gonna avoid using array completely. So I'm gonna write ARR is equal to np.array and I'm gonna pass a list to it. So I have passed the list. As you can see, so I've created an array. So here we won't use a Boolean index list. So in previous lecture, we filtered using Boolean index list and filter methods, but here we won't use a Boolean index list. Will you do it directly because it's the direct approach. Now let's proceed to creating the filter or creating the filtered array. So first we have to create a filter and then we can create a filter array. So this is the filter. So filter is equal to array name greater than 42. So it will filter all the elements which are greater than 42. And new array is used to store this result of the filter. So note that filter actually filters and new array is actually storing the result of the filter. So I'm gonna print the new array. Here you can see that it's an empty list because there's no value which is greater than 42. Now let's change the value and so it's now 3. So it will filter out all the elements which are greater than 3. So I've created a filter, I've stored the result in a new array and I have printed the new array. So all the elements greater than 3 were printed. Now you can see that I did not use a Boolean list directly in this example. But let's understand what is actually happening at the back end. So we need to observe, we need to understand. So please try to understand this clearly. So I was saying that we did not use a Boolean index list directly, but we still have a Boolean index list here. It is not direct, it's not visible to us, but it is still present. So let's see how. So when we executed the command, that is filter is equal to array name or ARR greater than 3, it kind of creates a Boolean index list. So the list is present, but it is not visible to us. So let me just print the result of this filter directly instead of storing the result in a new array. So if I print filter, I get a Boolean index list. So a Boolean index list is present here, but it's not visible to us, and it's working in the backend. So there is a Boolean index list, but we did not create it explicitly. We have not created a Boolean list directly as we did in the previous example. So we can say that this is a direct method. Now let's see one more example. So our objective in this example is to sort the even elements from the array directly. So we have to sort even element from the array, and we have to follow the direct approach. Now I'm gonna write the command for the filter. So filter is equal to array name mod of 2 equal to 0, because this is the condition to sort the even elements from the array. Now I'm gonna store the result in a new array, and I'm gonna print the new array. I made a little mistake here. Instead of giving the proper brackets, I gave the square brackets. So I have to rectify it and write it again. So all the even elements have been displayed. So we got the even values in the array or original array. So similarly, we can do it for the odd elements or the odd values. So in today's lecture, we covered the direct approach for filtering the array. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates. And stay tuned with us for next video. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we started our discussion on filtering of NumPy arrays, and we discussed two methods of filtering arrays, that is using Boolean index list and filter method. Today we are going to look at another method, that is the direct method. So let's get started. So filtering is a quite common task in NumPy. So there is an easy method to do it. We can directly substitute the array instead of the iterable variable in our condition, and it works just fine. It will be clear when we look at some examples. So let's move on to the code. Let me just write Python 3 and hit enter. Now I'm gonna import NumPy as np and hit enter. Now let's create a filter directly. So creating filter directly from the array. That's what we are gonna do. So to create a filter, we need an array first. So let's create an array first to filter out the values from the array. So we have to write array name or ARR or array or whatever you want. I'm gonna avoid using array completely. So I'm gonna write ARR is equal to np.array, and I'm gonna pass a list to it. So I have passed the list, as you can see. So I've created an array. So here we won't use a Boolean index list. So in previous lecture, we filtered using Boolean index list and filter methods, but here we won't use a Boolean index list. Will you do it directly because it's the direct approach. Now let's proceed to creating the filter or creating the filtered array. So first we have to create a filter and then we can create a filter array. So this is the filter. So filter is equal to array name greater than 42. So it will filter all the elements which are greater than 42. And new array is used to store this result of the filter. So note that filter actually filters and new array is actually storing the result of the filter. So I'm gonna print the new array. Here you can see that it's an empty list because there's no value which is greater than 42. Now let's change the value, and so it's now 3. So it will filter out all the elements which are greater than 3. So I've created a filter, I've stored the result in a new array, and I have printed the new array. So all the elements greater than 3 were printed. Now you can see that I did not use a Boolean list directly in this example. But let's understand what is actually happening at the back end. So we need to observe, we need to understand. So please try to understand this clearly. So I was saying that we did not use a Boolean index list directly, but we still have a Boolean index list here. It is not direct, it's not visible to us, but it is still present. So let's see how. So when we executed the command, that is filter is equal to array name or ARR greater than 3, it kinda creates a Boolean index list. So the list is present, but it is not visible to us. So let me just print the result of this filter directly instead of storing the result in a new array. So if I print filter, I get a Boolean index list. So a Boolean index list is present here, but it's not visible to us and it's working in the backend. So there is a Boolean index list, but we did not create it explicitly. We have not created a Boolean list directly as we did in the previous example. So we can say that this is a direct method. Now let's see one more example. So our objective in this example is to sort the even elements from the array directly. So we have to sort even element from the array and we have to follow the direct approach. Now I'm gonna write the command for the filter. So filter is equal to array name mod of 2 equal to 0, because this is the condition to sort the even elements from the array. Now I'm gonna store the result in a new array and I'm gonna print the new array. I made a little mistake here. Instead of giving the proper brackets, I gave the square brackets. So I have to rectify it and write it again. So all the even elements have been displayed. So we got the even values in the array or original array. So similarly, we can do it for the odd elements or the odd values. So in today's lecture, we covered the direct approach for filtering the array. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates and stay tuned with us for next video. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we covered the direct method for filtering of NumPy arrays, and today we are going to do some more examples on array filtering. So let's get started. So we covered three methods of array filtering so far, that is using Boolean index list, the filter method and the direct method. We also filtered the even and odd elements of a sequence using filter method and direct method. Now let's see how can we filter the even and odd elements of a sequence using the Boolean index list, because in previous examples we used to specify the Boolean index list beforehand. But now we are going to create Boolean index list using the append method. That is, first of all, we'll create an empty Boolean list and then we'll insert the element as true or false according to a certain given condition. So let's move on to the coding part. So I'm gonna open my terminal, write Python 3 and hit enter. Now I'm going to import NumPy as np and hit enter. So let's create a filter array that will only return even values from the original array or original sequence. So first of all, we need to create an array and then we are going to create a filter array that will return only even values from that array. So I've created an array. I'm gonna hit enter. Now I'm going to create an empty filter first. So the filter is empty, it does not contain any Boolean value initially. Now I'll create a for loop, and if the element is divisible by 2, that is the mod is equal to 0, then I'm gonna append true value in the filtered array. So if it's even, the corresponding element in the filtered array will be true, and if it is odd, the corresponding value in the filtered array will be false. So we did not initially specify the value in the filter, but we are appending the values based on certain conditions. Now I'm gonna store the values in the new array. So I have stored the values in a new array. It is giving me an error because of the wrong brackets. I need to use a square bracket here. So please keep these things in your mind while executing your code. Otherwise, you will get an error like me. So I need to change the brackets that I did, and I'm gonna print the new array now. So print new, it is giving me all the even values in the array. So we got the result as even elements. Let's understand what actually happened. So this thing appears quite complicated when we observe it for the first time, because you might be wondering why create an empty filter first and then insert the true or false values in it. We do it because we don't know beforehand that what values are we gonna get. So sometimes we have to take the array as input from the user. So that's the case. Now what actually happened is the filter stored the Boolean values that were assigned with the help of loop, or that were appended to the filter array. So the array filter is nothing but a Boolean index list which was used to iterate, which was used to filter the even elements from the array with the help of iteration and using a for loop. Now for odd elements, we need to follow the same procedure. We just need to change the selection condition, that is array name or ARR mod of 2 not equal to 0. In this case, we have to append true. So I have to change the condition. So in case of not equal to 0, I have to, in case of not equal to 0, I have to store true, or also I can do is in case of equal to 0, I can append false, and otherwise I can append true. Else filter dot append true. So you can follow any of the two approaches that I have suggested. So now I'm going to store the result in a new array, and so it is giving me an error. Exactly, it should give me an error because there are now 20 values in the filter, because 10 were the initial values from the previous example and 10 values are from this example. So filter has 20 values, which is why we are getting an error message. So please be careful because you might do the same mistake. Now the error is that filter already contained some values and we added values to it. So what you can do is that you can create a new filter and then you can store the result in a new array. So I'm giving you this thing as an assignment. Create a new array, a new filter, a new array instead of using the same code. So this is your assignment. So an assignment is to create a filter for filtering odd values or odd elements from the same array which we used in this example. Now we have one more assignment for you. So the second assignment is to create a filter for filtering the elements from the array in the given example. So filter the elements from array in given example, or in this video lecture, which are greater than 4. So in this video, we discussed some examples based on filtering using Boolean index list. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates. And stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our last lecture, we did some examples on array filtering. And today we are going to study how to calculate mean, median, mode, and standard deviation using NumPy methods. So let's get started. So as you must be knowing, mean, median, and mode are the measures of central location of data, and standard deviation gives us the extent of deviation of the data about the central location. These measures are of utmost importance while analyzing any data. So let's get started with the coding part. Let me open my terminal. So I'm going to write Python 3, hit enter. Now I'm going to import NumPy as NP. So first of all, let's talk about, or let's take a look at the measures of central location. So as you must have studied in statistics at some level about the measures of central location. So there are three main measures of central location. They are mean, median, and mode. As we know, the mean refers to the average value of the data. Similarly, the median refers to the middle value of the data. So median divides the data sets into two equal parts. And finally, the mode refers to the most common value. It is also known as the most repeated value of the data sets. Now let's calculate the measures of central location using NumPy methods. For that, we need to create an array first. So let's create an array and calculate all three measures of central location for that particular array. So I'm going to create an array with name x. So x is equal to np.array, and I'm going to pass a Python list. So this is our data. So it can contain any random values, but make sure that it has some repeated values so we calculate the mode. Otherwise, it will be a multimodal data set. Now let's start with calculation of mean. So let's first calculate mean, and we are going to use the standard formula. So what is the standard formula? Standard formula is the one that you use. Like you calculate the sum and you divide by the number of samples or number of observations. So this is not a NumPy method. It is the general formula that we use, or we are using since 4th or 5th grades. So we need to find the sum of all the samples or all the values, and we have to divide by the number of values or the number of samples. So let me just add all the values and divide it by the number of values. So what is the number of values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have total 15 values or 15 samples. So I have to divide by 15. So divided by 15, close the bracket and hit enter. So this is the mean, that is 3.533333 and so on. Now let's use the mean method, which is the method of NumPy. So I just need to write print np.mean and I have to pass the array name. We can see that we obtain the same result in both the cases. So I don't need to add all the values and divide it by the number of values, because if we have a very large data set, it will be difficult. So it's easier to use the standard method offered by NumPy. Let's calculate median now, which is the middle value. So to calculate the median, we should have a sorted array. Now the question arises that why do we need a sorted array? So if you are in a state to recall the method you followed in your primary school, that we just need to sort the array in a sorted order, whether ascending or descending, and we just need to circle out the middle value. So you need to count from beginning and count from back, and the value where you meet by taking unit step at a time, so that value will be the median. And in case you get two values, it will be the average of those two values. So here I have obtained the array in a sorted order using the sort method of NumPy. Now the middle value, as you can clearly see, is 3. So median of this data is 3. Now let's use the median method. For that, I just need to write print np.median and I need to pass the array name. So as you can see that the answer is 3. So now let's calculate or move on to mode. So let me just obtain the sorted array again. As you can clearly see in the sorted array, 2 is repeated 5 times. So it is the most repeated value. So mod of this data set or data is 2. Now let's use the mod method. Now the procedure is same. Print np.mode and pass x, but you got an error this time. So here's the catch. NumPy does not offer any method to calculate mode. So there is no inbuilt method in NumPy to calculate mode. So you must be wondering how to calculate mode then. I'll get back to that topic in a while. First of all, let's explicitly mention this error, because there is a very high probability that you will make the same mistake and get the same error while calculating the measures of central location, because other central location measures can be calculated by NumPy methods, but for this you need a SciPy method called as mode. So I got an error because mod is not an attribute of NumPy, it's an attribute of SciPy or scientific Python. We'll discuss this library in detail later on. We will create a separate playlist for SciPy. For now, just look at what I'm going to write and copy paste the same thing in your command prompt or your terminal or whatever IDE you are using to implement this code. So from SciPy, import stats. So stats is a module of SciPy. So print stats.mod x. So the result is 2 and the count is 5. This shows that the mod of the given data is 2 and it has occurred 5 times. So it shows the mod as well as the count of that mod. Count just refers to the number of time a particular value occurs. So don't be worried for now. Just copy paste the same thing. If you're not able to understand, it's not a big deal. We are going to explain it in detail later on. Now let's move on to calculation of standard deviation. Standard deviation is a measure of deviation, dispersion, how much the data deviates from the central value. In this case, it's going to be mean because you can calculate standard deviation around mean, median as well as node. But this inbuilt method is only for mean because most important measure of standard deviation is standard deviation about mean. So I just need to write print np.std and I need to pass the array name and I got the result. And this is the most important thing to note, that it gives the standard deviation about mean. Now I have an assignment for you. Calculate the standard deviation using the correct formula. So this time you don't need to use this inbuilt method. You just do it using the standard procedure that you follow in probability and statistics, and please match both these values. They will be same, but I want you to calculate it manually so that you can verify the result. And you need to check whether the theoretical value coincides with the calculated value. So in today's lecture, we covered the measures of central location, that is mean, median and mode, and we also demonstrated the use of STD method for calculation of standard deviation. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our last lecture, we covered the measures of central location as well as we calculated the standard deviation. And in today's lecture, I'm going to explain and demonstrate the use of arange and linspace methods of NumPy. So let's get started. Let me open my terminal. So first of all, I'm going to write Python 3 and hit enter. So what is arange method? That's going to be our first topic. So NumPy arange is one of the array creation routines in Python. So array creation routine is just a method to create an array. So arange method is one of the array creation routines or array creation methods based on numerical ranges. It creates an instance of nd array with evenly spaced values. So it creates an instance of nd array with evenly spaced values and returns the reference to that array. In simpler words, because I know that complicated definitions are a little difficult to understand. So in very simple words, or in beginners or rookies words, it returns a list of integers between the start and stop parameters. So it returns a list of integers between the start and stop parameters or values, including the start value but excluding the stop value or the end value. So it's pretty simple now. It's a method to create an array. So that array will contain a list of values which will be evenly spaced, and they will be between a start and a stop value. So let me just write array is equal to np.arrange and pass a start value and a stop value. Sorry, I have not imported numpy as np first, so it's giving me an error. Let me just import and do the same thing again. So array is equal to np.arrange and I need to pass 0 and 11 as start and stop value, and I need to print the array. So you can see that I passed 0 and 11. So I got all the integers between 0 and 10 and not 11. So 11 is not included. So this returns us numbers from 1 to 10. And one thing to note is that 11 is not included. So that's an important observation and an important thing to keep in mind while working with arange method. If you might have observed, arange method is very similar to the Python range method. So if you are not acquainted with the range method, please refer to our playlist on Python. Another important attribute of the arange method is the step size. We can also specify the step size. So let me just specify this step size as 2. Now I am printing the array again, and now I got only the even values. So note that this returns us the even values or the even numbers from 0 to 11. So whenever there is a question that create an array of even numbers between a starting and an ending value, you can always use arange method and specify the step size as 2. So we can specify whatever step size we require. Now let's move on to the linspace method. So we discussed the arange method, which is very similar to the range method in Python. And now we are going to move to linspace method and see what is the difference between arange method and the linspace method. So the linspace method returns evenly spaced points or elements between a start value and an end value. So it returns evenly spaced points or elements between a start value and a stop value. But an important thing to note here is that they don't need to be integers. So arange method always returns us integers, but linspace method will return us evenly spaced values or evenly spaced points, but they will not be integers. So the syntax is numpy alias or np.linspace. We need to pass start, stop, and the number of elements or the number of points that we need or require. So note that the difference between the linspace and arange is that linspace does not necessarily return integer values. This is a very important point to emphasize. That's why I'm repeating it multiple times so that it gets into your head directly. So don't confuse linspace with arange method because it returns integer values only. So now I'm going to demonstrate the use of linspace method. So you need to follow the syntax as described earlier. So the start is 0, end is 5, and number of values required are 10. So it gives me 10 values. Another important observation here is that it returns the start value as well as the end value. Yes, so that's another difference between linspace and arange method, because arange method excludes the end value, while the linspace method includes the end value. Now, the next example is obtained 100 points between 0 and 1, which are evenly spaced. So this time I need to specify the start as 0, the end as 1, and the number of values required as 100. Now I have printed the list. So it gives me 100 values between 0 and 1, and it includes 1. So that's the difference. Now I have an assignment for you. Obtained 50 evenly spaced values between 6 and 9 using linspace method. So that's your assignment. I hope you complete it. So in today's lecture, we studied about arrange and linspace methods of NumPy, and I demonstrated the use of both. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we studied about the arrange and linspace methods of NumPy, and today we are going to see how to create an array containing all values as zeros or ones, and also how to create identity matrices in NumPy. So let's get started. So I've opened my terminal. I'm going to write Python 3, hit enter, and I'm going to import NumPy as np. So our first job is to create a 1D array with all elements as zeros. So creating a 1D array of all zeros, or an array in which all the elements are 0. So the syntax is array name is equal to NumPy alias or np dot zeros, and I need to pass the number of values. So number of elements or number of values is going to be the parameter in this case. Now let's create an actual array by following the syntax. So array name is equal to np.zeros, and I'm going to pass 5 as the number of values, and I'm going to print this array. So I got the result as an array containing 5 zeros. Now let's create a 2D array or a matrix in which all the values are zeros. So in this case, I need to pass a tuple to this method, that is rows and columns. In last case, I only passed the number of elements, but in 2D array we have rows as well as columns. So we need to pass a tuple containing number of rows and number of columns. So we need double brackets here because it's a tuple. We are passing a tuple and not a scalar. So the syntax is same with slight change. So I have created a 2D array of all zeros containing 3 rows and 4 columns. Now let's create a 1D array of all ones, or an array in which all the values are 1. So syntax is same as zeros, but we need to replace the word zeros by ones. So syntax is same as the previous example. We just need to replace the word zeros by ones. It's same as we do in physics, like we replace m1 and m2 by q1 and q2, and the formula changes from Newton's law of gravitation to Coulomb's law, with different constants of course, but it's a slight change. So please take a joke and let's move on. So I need to write array name is equal to np.ones, and I need to pass 5 because I'm creating an array of ones which contains 5 ones, or in which the value 1 occurs 5 times and the only value present is 1. Now let's create a 2D array of all ones. So syntax is same. We need to pass a tuple this time with number of rows and number of columns that we want. So I specified that I need an array of all ones, a 2D array of all ones with 3 rows and 4 columns. So I got the relevant or the required result. Now let's see that how can we create identity matrices. So for those who don't know what is an identity matrix, so it is a special type of matrix in which the diagonal elements are 1 and rest of the elements are 0. And by diagonal I mean the main diagonal, which starts from top of left side and ends at the bottom of right side, because there are two diagonals but there is only one main diagonal in a matrix. So we can use the I method to create the identity matrix, and in this case we have one parameter, that is the order of matrix, because an identity matrix will always be a square matrix. So it returns a matrix and not a vector. So syntax is np.I, and I need to specify order, and order is 5 in this case. So in today's lecture we studied how to create an array with all values as ones or zeros, and also demonstrated the method to create an identity matrix. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we studied how to create an array of all zeros and ones identity matrices, and today we are going to get acquainted to random module in NumPy and its related methods. So let's get started. So first of all, what are random numbers? So random means something which can't be predicted with help of logic. It does not necessarily mean getting a different number every time or a different value every time. NumPy offers the module random to work with random numbers. Now let's try to understand the difference between true random and pseudo random. We all know that computers execute programs, and programs are a set of instructions with definite meaning. So programs are used to implement some algorithms to solve specific problems. So there must be an algorithm to generate a random number. Now the question arises, if some algorithm or program is used to generate a random number, the random number generated with the help of algorithm can be predicted. So it's not true random, because as per the definition of the random number, we can't predict random number with any kind of logic. So we can say that the random numbers generated by algorithms on our computers are not true randoms. They are referred to as pseudo randoms or false randoms. So whenever we work with randoms in our programs, we work with pseudo randoms. Now let's move on to the coding part. So let me write Python 3, hit enter. Now let's generate a random number with type float and by using rand method. So we are going to generate a random number which will be of the type float, and we'll do it with the help of rand method of the random module of NumPy. So I'm going to import NumPy as np and write x equal to random dot rand and hit enter. So here one thing to note is that it gives us an error because we have not imported the random module directly from NumPy. So we need to use NumPy alias with random and rand. So I'm going to write np.random.rand method and I'm going to print x now. So I got a random number. So note that this returns a random number between 0 to 1 and it's of the type float. So random number of the type float between 0 and 1. So now I'm going to show you another method to import random directly. So now let's import random directly. So we don't need to use np in this case. We don't need an alias. We can just write random.rand directly. So for that, we have to import the random module directly from NumPy. So in this case, I'm going to write from NumPy import random. So from NumPy import random. So now I can directly use random.rand method and I don't need to write np.random.rand. So directly write random.rand and print the value of variable in which you have stored the result. So I got the random number. So note that the values are different. So the values in both the cases are different because we are working with random numbers and it absolutely makes sense to get a different value each time we are calling the function. So we are getting different values and they are correct. So there's an assignment for you. Generate a random number between 0 and 100. Sorry, it is 0 and 1. I have just missed the decimal and it should be of type float. So today's lecture was an introduction to the random module and use of rand function in NumPy. That's all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we started with the random module in Python and I demonstrated the use of rand method of random module to generate a random number. Today we are going to cover rand method in detail. So let's get started. Let me just write Python 3, hit enter. Now I'm going to import NumPy as np and let's start our discussion on rand function or the rand method. So the rand method returns random number or numbers, or I can say that random sample or samples of type float between 0 and 1. So it returns random samples of type float between 0 and 1. So samples are taken from a uniform distribution. This is a very important point So it returns random samples of type float between 0 and 1, and samples are taken from a uniform distribution. We have a lot of distributions of different kinds, and this rand function takes samples from a uniform distribution. So the syntax is x equal to np.random.rand as discussed in the previous lecture. Now we have to print x to get a random number between 0 and 1. So now what if we want more than one sample? So this example generated one random number. Now what if I want an array of random numbers between 0 and 1 and the samples which belong to a uniform distribution? So the syntax is np.random.rand, and I need to specify the number of samples. So now let's generate 5 random numbers of type float between 0 and 1. So the syntax is x is equal to np.random.rand, and I need to pass 5 as parameter, denoting that we are going to generate 5 random numbers. So I got the result. So we get a list as a result. Now let's generate a 2D array or a matrix with the help of rand method, and all the values of that matrix will range between 0 and 1. They will be random and they will be the samples of a uniform distribution. Now I just need to write x equal to np.random.rand, and I need to pass rows as well as columns, and I need to print x. So I got the result as a square matrix because I have passed equal number of rows and columns, but you can pass different parameters like less value of row and more value of column, or vice versa. So we got a matrix as a result with 5 rows and 5 columns. So now there is an assignment for you. Create a matrix with the help of rand method of 2 rows and 1 column. So in today's lecture, we covered the rand method of the random module in detail. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we covered the rand_n method, and today we are going to cover the rand_n method of the random module of the NumPy. And we'll try to understand what is the difference between the rand method and the rand_n method. So let's get started. So let me just write Python 3 and hit enter. Now I'm going to import NumPy as np and hit enter. So I've imported the NumPy library. Now the NumPy dot random dot rand n method. Here we have not imported the random module directly, so we will use NumPy or np.random.rand n as the whole syntax. So it creates an array of specified shape and fills it with values or numbers as per the standard normal distribution. So it creates an array of the specified shape and fills it with the values as per the standard normal distribution. Now, if you recall, in case of the rand method, it fills the array with values as per the standard uniform distribution. This is a very important difference between the rand and the rand in method. So one important thing to note is that it fills the array with random floats sampled from a univariate, normal, or we can say Gaussian. So the RAN method takes samples from a normal or Gaussian distribution. And mean of that Gaussian or normal distribution is 0 and the variance is 1. We'll cover the uniform and normal distribution later on. This is just a brief intro. Now, note that normal distribution is a distribution which is continuous in nature. We have a lot of different kinds of distributions in statistics, like uniform distribution, normal distribution, Poisson distribution, Rayleigh distribution, etc. So, normal distribution is a kind of continuous distribution and it has a probability density function as opposed to the discrete distributions which have a corresponding probability mass function. Now, an important thing to note is that if we provide no argument in this rand in method, then it will return a randomly generated float which will be sampled from the distribution, or we can say from the normal or Gaussian distribution. So this is a very important thing to note. So if we provide no argument, then a single float randomly sampled from the distribution is returned. So please keep a note of that. Now we'll start with the code, and first of all I'm going to pass no argument. So I'll write x is equal to np dot random dot rand n, and I'm going to pass no parameter, and I'm going to print the value of x. So I got one random number which is sampled from a normal distribution which is centered around 0 with mean 0 and variance 1. Now I'll create a 1D array. So I need to pass one parameter and I need to print the value of x. So this is the result. So as a result, we got a 1D array, or I can say that a row vector. So the result is a row vector or a 1D array. Similarly, if I want to create a 2D array, I need to pass two parameters, that is the row count as well as the column count. So now let's create a 2D array or a matrix. So I need to follow the same syntax. I just need to give two parameters this time. So let it be 4 and 3. Now I'll print. So I got a matrix with 4 rows and 3 columns. So the result is a 2D array, or I can say a matrix. Now let's create a 3D array. So the syntax will be same. I just need to pass 3 parameters this time, because a 3D array has 3 dimensions. So I need to follow the same syntax. I just need to give 3 parameters. And I'll print the value of x again. So you can see that I have got a 3D array as a result. So result is a 3D array, or I can say that a third order tensor. Because if you recall, in higher dimension, nth order array is referred to as nth order tensor. Now I've got an assignment for you. Create a 4D array randomly using the randn method and print it. So in today's lecture, we covered the use of randn method of the random module of NumPy. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we covered the randn method and today we are going to learn about the randint method of the random module of NumPy. So let's get started. So let me just write Python 3 and hit enter. Now I'm going to import NumPy. So I'm going to import NumPy as np, hit enter. So today we are gonna discuss about the randint method. So randint stands for random integer and it is an inbuilt function offered by the random module of NumPy. So it's an inbuilt function like rand and randn, and it's also a function of the random module of NumPy. So you know that the random module gives access to various useful functions. So the module random gives access to various useful functions and one of them is randint, which is able to generate random integer numbers. So the rand and randn functions generated float values, but this function generates random numbers and they are of type int. Now let's move on to the syntax. So the syntax is you have to write np or numpy dot random dot randint and you have to pass the start, the stop value. So you have to give a range within which you want to get a random integer. So this is the syntax. And also note that both the start and stop values must be integers. So the start stop values indicating the range must be integer values. Otherwise, you will get an error while executing the statements. So now let's just write x is equal to np dot random dot randint. So dot randint and pass the start as well as the stop value. And now I'm going to print the value of this randomly generated integer. So it's 8 in this case. You may get a different value because we are working with random numbers. Now let's move on to some more examples. So next example is generate a random number between -10 and -1 and it should be of the type integer. So I'm gonna write x is equal to np.random.randint and I'm going to pass the start as -10 and the stop as -1. Now I'm going to print the value of x, and it comes out to be -3. So I have generated a random number of type integer between -10 and -1. Now let's see what happens when we pass non-integer values. So x equal to np dot random dot rand int, and I'm going to pass non-integer values. Let's see what happens. Ideally, it should give us an error. So I'm going to pass the float values, and I'm going to print the value of x now. So I'm going to write print x and hit enter. Now you guys must be wondering that we got a result, but we should get an error. So this is because there might be an update. I guess now we can use compatible data types as start and stop values. Now let's try using non-compatible data types like string or character values. So I'm going to pass character values this time, or string values. So it gave me an error. So invalid literal for int with base 10. So this is a non-compatible data type. So note that we got an error with non-compatible data type. And in the previous versions, if you try float values also, you will get an error, because now there might be an update, but in previous version, it gave us an error. Now there's an assignment for you. Generate a random number between -5 and let it be 4 and 4 using rand int method. So in today's lecture, we covered the rand int or the random integer method of random module of NumPy. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we covered the randint method, and today we are going to do some more examples based on the methods offered by the random module of NumPy. So let's get started. So let me just write Python 3, hit enter. Now I'm going to import NumPy as np and hit enter. Now today's topic is some more examples on the methods offered by the random module of NumPy. So we'll try to do some mixed examples. So first question is, create a 1D NumPy random array and sort it. So we have to create a 1D NumPy random array and we need to sort it. So let's move on to the solution. First of all, let's create the array. Let the array name be A. So A is equal to np.random.rand, and let the number of elements be 6. Now let's print the sorted array. So I have to write print, and in bracket I have to pass np.sort, and in sort I have to pass E. So this is the sorted array. You can see that it has been sorted according to the ascending order. So if we got the sorted array and we use rand method to create a random NumPy array, or we can say we use the rand method of the random module of NumPy to generate a random array, and we used the sort method of NumPy to sort the array. So this was a mixed example. Now let's move on to the next problem. So next problem is problem number 2. Create a 2D matrix of dimensions 2 cross 3. That means 2 rows and 3 columns. So create a 2D array or matrix with dimension 2, 3 that contains 6 random numbers between 2 and 6. So let's move on to the solution. So I have to write array name or ARR is equal to np.random.rand int. This time I need an array that contains integer values, and I have to pass the start, stop as 2 and 6, and I have to pass the dimensions of array as a tuple. So that is 2, 3. Now I'm going to print this array. So you can see that I got a 2D array with dimensions 2, 3 or 2 rows and 3 columns, and it contains random numbers or random integers between 2 and 6. So here we constructed a 2D array or matrix with the help of randint method. Now let's move on to our third example or third problem. So problem number 3 is use NumPy random number function to generate at least 1000 numbers between the range of 1 to 1 lakh or 100,000. And after generating, we need to perform some operations. So we have to generate an array of 1000 numbers, and the range is 1 to 1 lakh or 100,000, and we need to perform some operations on it. So let's move on to solution. So first of all, let's create the required array. So I'm going to write ARR is equal to np.random.randint, and I'm going to pass start, stop, and the number of elements. So in this case, it's 1000. So size is 1000. Now the first operation is, or I can say that the first part of the question is to sort these elements. So I've created an array with random integer numbers from 1 to 100,000, and now I need to sort these elements and store them in a new array. So the new array name or ARR new is equal to np.sort, and I'm going to pass the array name. Now I'm going to print the original array first. So you can see that it contains randomly distributed numbers, and I'm going to print the new array now. So it is sorted. Now I'll scroll so that you can see clearly. The first one was the randomly arranged numbers, and second one is the sorted array. Now The second part is to determine the maximum and minimum element. So part 2 is to determine the maximum and minimum element from this array. So we need to write min element or min ele, whatever variable name you want to give, and that is equal to np dot min, and we need to pass the array name. And similarly for the max, just replace the min by max. And I'm going to print these values now. So print min ele as well as print max ele. So the minimum element is 268 and the maximum element is 99905. You may get different values as we are working with random numbers. Now the third part of the question is to determine the average, or we can say the mean. So for that I have to write ARR mean or whatever variable name is equal to np dot mean, and I have to pass the array name, that is ARR. Now I'll print it. So the mean of all the values is around 50,252.304. And now fourth part of the question is an assignment for you, that is find the mod, the median and standard deviation for this data contained in the array. So in today's lecture, we solved some questions based on the methods offered by the random module of NumPy. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we solved some examples based on the methods offered by the random module of NumPy, and today we are going to take a look at random permutations. So let's get started. Today we are going to execute our code in the Jupyter Notebook. I'll teach you how to set up Jupyter Notebook in the next lecture. So let's start with today's topic. So a random permutation refers to an arrangement of elements. For example, take an array with the values 4, 3, 2, 1. So it is a random permutation of 1, 2, 3, 4 and vice versa. So just with a sequence, we can make several different arrangements or combinations. So they are called as permutations. So a lot of other permutations are possible as well. But the NumPy methods which we are going to study today, they give only one permutation on passing a sequence. So we get only one random permutation on passing a sequence or an array. So a lot of permutations are possible that can be calculated using the formula npx, but here we'll get only one random permutation by using methods of NumPy random module. So NumPy random module has two methods to find out the random permutation. The first method is the shuffle method. So for that I need to create an array first. So I've created an array, and now to get a permutation I need to write np.random.shuffle and I have to pass the array name. Now I'm going to print the shuffled array first to get a permutation. So it gave me an error because I have not imported NumPy. So let me just import NumPy as np first, and let me run this cell again. Now let me just print the array after shuffling. So I got the result as 42135, which is a permutation of 12345. Also note that this shuffle method makes changes to the original array. So if I write print np.random.shuffle and I pass the array name, I'll get no result or the result as none. Now the second method is using the permutation method. So now let's create an array again, the same array. We created the same array again because it has been shuffled. So now I created the array again and I use the method permutation. So I need to write np.random.permutation and I need to pass the array name as arr. So I got another permutation of 1, 2, 3, 4, 5. Now let me print the original array as well. So I'll print array name or arr and I'll hit enter or run this cell by shift plus enter. Now I got the original array as well as you can see the array after permutation. Now shuffled array makes changes to the original array while the permutation method does not make changes to the original array. Please note this. This is a very important observation to make. Also note that if you want changes in original array, you need to use the shuffle method, and if you don't want any changes in the original array, you need to use the permutation method, because you need to choose according to the situation that you are in. Now there's an assignment for you. Create an array using rand int method. So create an array using the rand int method of the random module of NumPy. Sort that array using sort method, and the third objective is to find the random permutation for that array. Or the sorted array. So in today's lecture, we covered random permutations and the shuffle and permutation method to obtain a random permutation. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we covered random permutations, and today I'm going to teach you how to install Anaconda, get started with the Jupyter notebook, and how to install Seaborn and Matplotlib libraries. So let's get started. So I'm sharing my screen. I'm going to Safari. So you can go to your browser and you can search Anaconda. So it's showing the name of website as I had already installed. So you can see the first search result as the name of the website. Now this is the website or the official website for installing the Anaconda package. So this is the website and you can click the download. Since I'm using a Mac, so I'll install it for Mac. If you are using some different operating system, it will show you the package corresponding to that particular operating system. Now it's downloading. So it's of around 620 MB for Mac OS users. It may vary according to whatever operating system you are using. Since I have already installed, I'm cancelling the download, but you need to complete the download. So there's one other method to download Anaconda if you are using a Mac OS and you have Homebrew support. So go to Homebrew and search Anaconda. So you will get a command to install Anaconda. So just copy it, open your terminal. So I'm going to open my terminal and just paste the command and hit enter. So paste the command and hit enter. Now it's taking a little bit time here. So running view auto update. So it has updated and it's showing Cask Anaconda is already installed because I have already installed Anaconda. So it's already installed. Now let's move on to installation of libraries that are Seaborn and Matplotlib. You can install these libraries using pip installer package or Anaconda. So here I'll be installing them using pip installer package first. So I need to write pip install Seaborn to install Seaborn. So it shows requirement already satisfied because it's already installed in my system. Now similarly for Matplotlib, I have to write pip install Matplotlib. So it will show requirement already satisfied again because I have already satisfied these libraries. Now let's see how to install them using Anaconda. So if you want to use Anaconda for installing these libraries, so you need to write the command conda install Seaborn, and the process will take some time. So there is some background process going on. So there will be some processing. So it shows done. So it's asking for a permission to install new packages. Since I have already installed, so I won't be proceeding with this. But since you're installing it for the first time, you have to proceed with Y. So you need to proceed with Y, and similarly, you need to install Matplotlib using the command conda install Matplotlib. So the process is similar. You just need to replace Seaborn with Matplotlib. So the command will be conda install Matplotlib. Let me clear the screen. Now let's open the Anaconda navigator. So open the Anaconda navigator and close the terminal. So I've opened the Anaconda navigator and it's showing a lot of options, but we have to select the notebook and click launch. So it will take a minute or 30 seconds and it will open in your browser. Don't worry, this process is offline. It doesn't require internet connection. So just create a new folder wherever you want to store your code. So I've created a new untitled folder for that. So I'll just open this folder by clicking on it. So it shows the notebook list is empty and I'm going to create a new notebook now. Now this is a cell. So in this cell, I'm going to import NumPy as NP. I'm also going to import Cbond as SNS and import matplotlib.pyplot as PLT. And I'm going to hit shift and enter to run this cell. So it gave me no error. So we have successfully imported these libraries. You can also rename the notebook by clicking on the name, that is untitled. So I'm changing it to my first notebook. So now there is an assignment for you. So assignment is that you need to practice some of the problems that we already discussed in the previous lectures in Jupyter Notebook. Because if you practice more, you'll get acquainted with this quickly. So practice some of the codes we have discussed in previous lectures in Jupyter Notebook. So in today's lecture, I demonstrated how to install Anaconda and also how to install Cbond and Matplotlib libraries using pip installer package as well as Anaconda. We also created our first Jupyter notebook. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our last lecture, I explained you how to install Cbond, Matplotlib and get started with the Jupyter notebook. And today I'm going to teach you the normal distribution. So let's get started. So as per Wikipedia, normal distribution, also known as Gaussian, Gauge, or Laplace-Gauge distribution, is a type of continuous probability distribution for a real valued random variable. The general form of its PDF or probability density function is given by f of x is equal to 1 by sigma into under root 2 pi multiplied by e raised to power minus 1 by 2 x minus mu by sigma whole square. Here f of x is the probability density function, mu is the mean of the distribution and sigma is the standard deviation. Now let's look at the plots. So these are the normal plots for different mean and for different standard deviation values. So one general observation is the distribution will always be centered around the mean. So in this blue curve, the mean is 0, so centered around 0. Same for red and yellow, but the green is centered around minus 2. And you can see that they are dispersed differently. Now let's take a look at the CDF curves. So these are the CDF curves. So three curves intersect at 0 because they have mean as 0 and one is passing through minus 2 because the mean is minus 2. So this was the CDF curve. Now let's move on to the coding or plotting part. So generate a random normal distribution of size 3 into 3 with, so we have parameters here. So the parameters are mean and standard deviation. So here mean is 1 and standard deviation is 2. So from NumPy import random. So from NumPy import random and proceed further. So x is equal to random dot normal, and we will specify the parameters, that is location is equal to 1, scale is equal to 2, and size is equal to whatever is the size of the distribution. So location means the mean, what the value around which the distribution is centered. So this is the returned array and the elements are the samples taken from a normal distribution. Now let's visualize the normal distribution. Visualization is a very important aspect because here we are dealing with Seaborn, NumPy as well as Matplotlib. So a combination of these three libraries helps us in visualization. The Matplotlib being the grandfather of the visualization libraries. So now let's visualize. Import matplotlib as matplotlib.pyplot as plt and import Seaborn as sns. Now sns.displot, and we are going to pass an array which contains samples taken from a normal distribution. So random.normal and size is equal to, so let the size be 1000 and hist is equals to false. So we have taken the hist as false because normal distribution is a continuous distribution. So we are just concerned with the KDE plot. So here I'm using Jupyter Notebook. So I taught you how to install all the libraries and get started with the Jupyter Notebook. If you have skipped that lecture, I advise you to go back and watch it again. So here I'm using the Jupyter Notebook, but if you are using any other platform, then you have to write plt.show, and here sometimes in Jupyter Notebook we also use %matplotlib inline explicitly for Jupyter Notebook also. Please note that normal distribution has a bell-shaped curve. So in today's lecture, we covered the normal distribution, the PDF and CDF of a normal distribution and their plots, and we created an array with values from a normal distribution, and at the last we visualized the shape of a normal distribution curve. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we covered the normal distribution, and today we are going to take a look at the binomial distribution, its PDF curve, and how to plot the PDF for a binomial distribution using NumPy, Seaborn and Matplotlib. So let's get started. So what is binomial distribution? So binomial distribution is a discrete distribution. It describes the outcome of binary scenarios. Example, toss of a coin, that is head or tail, winning or losing, passing or failing, etc. It has three parameters: n, the number of trials; p, the probability of success; and q, the probability against success. So its probability mass function is given by p of x is equal to k, that is probability that our variable takes on the value k is equal to nck p raised to power k into 1 minus p whole raised to power n minus k. So this is the probability mass function because it's a discrete distribution. Now let's see how a binomial distribution looks like. So in first case, n equals to 10. The probability of success is 0.5, that is 1 by 2. So in this case, the distribution is nearly symmetrical. About x is equal to 5. So for p is equal to 0.5, that is probability of success is half, then the distribution will always be symmetrical. Now let's take a look at the second case where value of n is small and the value of p is not equal to 0.5. In this case, the distribution will not be symmetrical, it will be asymmetrical. Now let's take a look at the last case. In this case, the value of p not 0.5, but it still looks symmetrical because here the value of n is very large. Also note that it just looks symmetrical. It is not symmetrical. It will only be symmetrical if p is equal to 0.5 or half. Now let's move on to the coding part. So let me just rename it to binomial and we are good to go. So here we have three important parameters. Also note that the parameters for different distributions will be different. So you have to memorize all of them in order to be able to plot all the distributions. So the parameters are n, denoting the number of trials; p, denoting the probability of success or the probability of trial; and size, that is the shape of the array returned. So these are the parameters. Now given 12 trials for a coin toss. So coin toss is a binary scenario and there are 12 trials, that is n is equal to 12, and the probability of trial or probability of success will be 0.5 because in a fair coin toss head and tail have equal probabilities. So we have to generate 10 data points, that is we have to take 10 samples from a binomial distribution where n is equal to 12 and p is equal to 0.5. So after analyzing the problem, we can say that here n is equal to 10, p is equal to 0.5 and size is equal to 10 because we have to generate 10 data points. I'm sorry, I made an error. N is not 10 here. N is equal to 12. So let me just rectify the error. So n is equal to 12 and size is equal to 10. Now let's move forward. Let's create a new cell. So now I'm going to write from NumPy import random. And now I'm going to write x is equal to random dot binomial and I'm going to pass the parameters. So n is equal to 10, p is equal to 0.5, and the size is equal to 10. So we'll get 10 samples from a binomial distribution as a result. So these are the 10 samples. Now we have obtained samples from a binomial distribution. Now let's move on to visualization of a binomial distribution. So let's visualize now. So I'm going to write. So let's first initialize the parameters. So let's n is equal to 10, p is equal to 0.5, and the size p, let it be 10,000. So these are the parameters with which we are going to plot a binomial distribution. So I'm going to write from NumPy import random and import matplotlib.pyplot as plt and import cborn as sns. Now sns.displot random dot binomial, and we have to pass the parameters here. Sorry, this is a different kind of cell. So let me just clear this thing. So let me just write import. Sorry, what was I writing? I just forgot. So it was sns.displot and pass the parameters. So random.binomial, and we have to pass the parameters. So n is equal to 10, p is equal to 0.5, and size is equal to 10,000. And we have to specify the hist as true because this is a discrete distribution and we are concerned with the histogram. And we can specify the KDE as false because we don't need kernel density estimation. That is important in case of a continuous distribution. The last cell was a text cell, so just let me copy paste and hit enter. So I got the plot for a binomial distribution, and this is the plot. You can see that it is almost symmetrical. It is not almost symmetrical. It is definitely symmetrical because the probability of success is 0.5, and whenever p is equal to 0.5, the shape will be symmetrical. So in today's lecture, I covered binomial distribution and its shape. That's all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates. And stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we covered the binomial distribution, and in today's lecture, we are going to cover the uniform distribution. So let's get started. So first of all, what is a uniform distribution? So it is a continuous distribution, and according to Wikipedia, in probability theory and statistics, the continuous uniform distribution or a rectangular distribution is a family of symmetric probability distributions. The distribution describes an experiment where there is an arbitrary outcome that lies between certain bounds that are a and b, and PDF is given by 1 by b minus a for all x belonging to a till b and 0 otherwise. Now let's take a look at the PDF. So this is the PDF and it's 0 for any value less than a and greater than b, and it is only defined between a and b, including both the values, that is a and b. Now let's move on to the CDF, or the cumulative distribution function. So here it's like a transfer curve and it has a slope from a to b. So this is the cumulative distribution function. Now let's move on to the coding part. Let me just change the name to uniform, and now I'm going to mention the important parameters of a uniform distribution. Also note that in uniform distribution, the probabilities are generally equal. The uniform distributions can be either continuous or discrete. And in discrete uniform distribution, the probabilities are same. But in a continuous distribution, the scenario is different. We deal with three important parameters here. That is lower bound, that is denoted by a and has the default value 0. B, the upper bound, having the default value 1. So B has the default value 1. And the third parameter is the size, that is the shape of the returned array. So size is the shape of the returned array. Now let me create a new cell, and first of all let's draw out some samples from a uniform distribution. So create a 3 cross 3 or 3 into 3, that is 3 rows and 3 column matrix consisting of values which are samples taken from a uniform distribution. Or in short, I can say that create a 3 cross 3 uniform distribution sample. I tried to add comments here, but it is not working. So let me just clear all this and just write it simply as a single line comment. So create a 3 cross 3 uniform distribution sample. Now let's move on to the next cell, and from NumPy I'm going to import random. So from NumPy import random, and x is equal to random dot uniform. Now we have to pass the parameters, that is size, and print. So this is a 2D array, and the elements of this 2D array are samples taken from a uniform distribution. Now let's move on to the visualization part. So let's visualize uniform distribution. So now I'm going to import random from the NumPy module by writing from NumPy import random, import matplotlib.pyplot as plt, import cborn as sns, and now I'll write sns.dispplot and I'll pass the parameters. So random dot uniform, and I have to pass the parameters such as size. So size is equal to 1000, So I have specified the size as 1000. You can specify a different size, and I am specifying the hist as false because this is a continuous uniform distribution. So it's not a perfect rectangular PDF as seen, but this is the actual thing that was theoretical. Now let's try to see the histogram as well. So it's in shape of a box, so that is much closer, but we are only concerned with the boundary and not the filled portion. So it's not true for a hist, it is true for a KDE, but it's not the perfect shape here. So that's all for today. In today's lecture, we covered a uniform distribution, its PDF, the CDF, as well as we visualized the uniform distribution. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates. And stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we covered the uniform distribution, and in this lecture we are going to cover the Poisson distribution. So let's get started. So first of all, Poisson distribution is a discrete distribution. It estimates how many times an event can happen in a specified time. For example, if we get 3 heads on continuously tossing a coin, what is the probability of getting 4 heads? That is one example of Poisson distribution, and its probability mass function is given by lambda raised to power k e raised to power minus k divided by k factorial, where lambda is the expected rate of occurrences. Now let's look at the PDF of a Poisson distribution. So here we have 3 different PDFs for 3 different Poisson distributions for different values of lambda. We note that the peakedness of the distribution depends on the value of lambda. Lesser the value of lambda, more will be the peakedness. Now, Poisson distribution is a discrete distribution. It has 2 parameters, lamp, that is rate or the known number of occurrences, and size or the shape of the returned array. Now let's write some code. First of all, we will create an array which will contain samples taken from a Poisson distribution. So let's generate a random 1 cross 10 distribution for occurrence. So we are going to generate a random 1 cross 10 distribution for lambda is equal to 3. So from NumPy, import random. So x is equal to random dot Poisson, and we are going to pass lamp or lambda is equal to 3 and size is equal to 10. Because it's 1D array, so we don't write size equal to 1 comma 3 in brackets, so we directly write 10. So this array contains samples which are taken from a Poisson distribution. Now let's move on to the visualization part. So visualization of Poisson distribution. Now I'm going to write. First let's import. So from NumPy, import random, import matplotlib.pyplot, as PLT, import cborn as SNS. Now I'm going to write percent matplotlib inline, and now I'm going to write sns.testplot. So sns.testplot random dot poi sorry it's yeah Poisson. So random dot Poisson, and I'm going to pass the lambda value and the size. So let the size be 1000, and lambda is equal to 3, and KDE is equal to false because this is a discrete distribution. And sorry, I've written matplotlib instead of matplotlib, so let me just correct it. So this is the plot. So this is how a Poisson distribution looks like. Now let's see what's the difference between Poisson and normal distribution, or difference between normal and Poisson distribution. So first of all, normal distribution is a continuous distribution and Poisson distribution is a discrete distribution. Normal distribution is used when we are predicting something on a continuous range, while Poisson distribution is used when we are concerned with an event and intervals of time. Let's see the plots in one frame. So sns.dispplot and random.normal. So let the location be 50, that is mean is 50, scale is equal to 7, and the size is equal to 1000. Now let me draw or plot a corresponding Poisson distribution also. So sns.dispplot random.Poisson, and I'm going to pass the parameters. So let the lambda is equal to 50, the size be 1000, and also let me label it so that we can see the difference. So label is equal to normal for the normal distribution, and table is equal to Poisson for the Poisson distribution. And let me hit shift enter. So now you can see the difference between the two. So in today's lecture, we covered the Poisson distribution, its PDF and its visualization. We also differentiated between a Poisson distribution and a normal distribution. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button, and stay tuned with us for more lectures. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we covered Poisson distribution, and today we are going to cover exponential distribution. So let's get started. So first of all, exponential distribution is used for describing time till next event. Example, failure, success, etc. The PDF is given by lambda e raised to power minus lambda x, and the CDF is given by 1 minus e raised to power minus lambda x. Here, lambda denotes the rate or the inverse scale and lambda should be greater than 0. Now let's take a look at the PDF and CDF curves. So this figure shows us the PDF curve and this figure shows us the CDF curve for different values of lambda. Now let's move on to the coding part. So exponential distribution is used to describe the time till next event as already discussed. It has two parameters, that is scale, that is inverse of rate and with default value 1, and size, that is the shape of the returned array. Now let's first draw out samples from an exponential distribution and store it in an array. So let's draw out a sample for exponential distribution with scale is equal to 2.5 and 2 into 2 size, that is 2 cross 2 size. So we have to draw out samples from exponential distribution and store it in an 2D array with size 2 cross 2. So I'm going to import random from NumPy. So from NumPy import random and x equal to random dot exponential, and I'm going to pass the scale, that is our first parameter, and I have to pass the second parameter, that is size. So size equal to 2 comma 2 denoting 2 cross 2 size, and now I'm going to print x. So this is a 2D array with 4 values which are sampled from an exponential distribution. Now let's visualize the exponential distribution. So visualization of exponential distribution. Now I'm going to again import random from NumPy. So from NumPy import random, import matplotlib.pyplot as plt, and finally import cborn as SNS. Now I'm going to write SNS.distplot, and I'm going to write random.exponential, and I'm going to pass the parameters, that is the value of lambda and size. Let's just pass size here and lambda will attain its default value, and mention the hist as false because this is a continuous distribution. So this is the PDF, that is probability density function curve for an exponential distribution. Now let's try to understand the relation between exponential and Poisson distribution. So Poisson distribution denotes number of, let me just move to the next line. So Poisson distribution denotes number of occurrences of an event in a time period where as exponential distribution or exponential deals with the time between the events. So in today's lecture, we covered the exponential distribution and visualize the PDF of the exponential distribution. Further, we tried to understand the relation between the Poisson distribution and exponential distribution. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our last lecture, we covered exponential distribution and today we are going to cover logistic distribution. So let's get started. So logistic distribution. So first of all, what is logistic distribution? So logistic distribution is used to describe growth. So logistic distribution describes the growth. And it is a very important distribution because if you are acquainted with machine learning, you must have heard of the term logistic regression. So it's a very important concept in machine learning data science. So this distribution is very important and it will be explained in detail once we move on to machine learning and data science. So logistic distribution is used to describe growth. It is a very important distribution and it is used extensively in logistic regression, neural networks, etc. And mathematical description will be given later on. I mean in the future courses on data science and machine learning. So today we are just going to visualize it and draw out samples from logistic distribution. So let me just create a new cell. So first of all, let's discuss the parameters. So it has three parameters: the log or the location or the mean. The place where we have a peak. Like in the previous lectures, we used to call it mean only, but here we are using log, or which denotes the location or location of the peak. And default value for mean or log is 0. And the second parameter is scale. It denotes standard deviation. And what is standard deviation, or what does standard deviation denote? It denotes the flatness or the peakedness or the deviation from mean. Central value, we have a central value, and standard deviation tells us how much our data deviates from that central value or the measure of central location, which is a mean in this case. We have other measures for central location, that is mod, median, but we prefer mean over others. So let's draw out samples from a logistic distribution. So let's draw out 3x3 samples from logistic distribution. And we need some parameters. So let the mean be 1 and standard deviation be 3. So we are going to write x is equal to random dot logistic, and in bracket we are going to pass the parameters, that is log or location is equal to 1, which denotes that the mean is 1, and scale is equal to 3, that means standard deviation is 3, and let the size be 2 comma 3. Sorry, 3 comma 3, because we want to have a 3 into 3 array. So I forgot to import random. So let's write a line for that. From NumPy import random. Now let's execute, and we got this array which has 3 rows and 3 columns, and all the elements of this array are samples taken from a logistic distribution of mean 1 and standard deviation 3. Now let's try to visualize the logistic distribution to see how the shape looks like. So from NumPy import random, and in next line here we'll directly import matplotlib.pyplot as plt and import cbon as sns. Now we'll write sns.displot, and we will pass random dot logistic, and in bracket we'll write the parameters, that is log or location or mean, the scale and the size. But here we are not gonna pass, let it acquire the default values. So we are only going to pass size, that is 100, and hist is equal to false, because this is going to be a continuous distribution. Now let's execute. So this is the pictorial form of the distribution, or we can say the graphical form of logistic distribution. So logistic distribution looks similar to normal distribution. As you can see that this shape is also like a bell. So the curve is also bell shaped, but you can see some difference in the tails of the distribution. So if you look around the values -6 to -10, the shape is little bit different than we had in the normal distribution. So it has more area under tails. So in today's lecture, we covered the logistic distribution, and we visualized logistic distribution along with comparison with normal distribution. That's all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates, and stay tuned with us. Hi guys, welcome back to our course on NumPy. In our last lecture, we covered logistic distribution, and today we are going to cover the multinomial distribution. So let's get started. Let me just rename the notebook to multinomial. So I have renamed the notebook, and let me just zoom in or maximize. So let's get started with multinomial distribution. So what is a multinomial distribution? So in simple words, we can say that multinomial distribution is just a generalization of binomial distribution. So in binomial distribution, we dealt with two events, but in multinomial distribution, we are dealing with multiple events. So in simple words, binomial distribution gives us information about two scenarios, where bi means two, and multinomial distribution gives us information about multiple scenarios or multiple events. So multiple. So this is the case where we have 2 scenarios and we generalize it for n scenarios. So example of binomial is toss of a coin that we have discussed earlier, that either head or tail, so two events. But in multinomial we have multiple events like occurrence of 1, occurrence of 2, occurrence of 3, or occurrence of 6 on toss of a die. So example of multinomial distribution is rolling of a die. So multinomial distribution has three parameters. We'll not be going into details about multinomial distribution because it's not concerned with subject matter at hand, but we'll have a general idea. So multinomial distribution has three parameters, that is n or number of outcomes, p-vals or the probabilities of the outcomes, that is list of probabilities of outcomes. So first we have number of outcomes, then we have list of probabilities of outcomes, and third we have the shape of the returned array. That is common almost for every distribution whenever we try to sample something, because after sampling we'll return something, right? The size, the number of elements returned. So the mathematics, that is PDF or CDF, will be discussed in future lectures. Today we'll emphasize on visualization of multinomial distribution and draw out conclusions if any. So let's draw out samples first. So let's draw out a sample. Let's take the rolling die experiment for this sampling. So let x is equal to random dot multinomial. Now we have to pass the number of outcomes, that is 6, the p-vals or probabilities of outcomes. Here in a roll of a die, the probability is 1 by 6 for each and every number. So each and every number has equal probability of occurring. This may not be the case for some biased experiments, so you keep that in mind. Here we have each probability value is equal to 1 by 6, and we need to import a random from NumPy. So from NumPy import random, so x. So this is the array returned. So there is a very important observation to make. The shape of returned array is not one, it is not a single element, but I didn't specify any size, so by default it should give me 1. That's what I thought, or that's what you must have thought, but it has returned an array with 6 elements. So an important point is that multinomial samples will not produce a single value, they will produce one value for each p-val. So keep this in mind. They will not produce a single value. They will produce one value for each corresponding probability value. Also, note that since multinomial distribution is an extension, or we can say that generalization of binomial distribution, So its shape the shape of its PDF will be same as the shape of PDF of a binomial distribution. So we'll not plot a multinomial distribution today. That is for you to do. That will be your homework or assignment task. So as a home assignment, plot a multinomial distribution. So in today's lecture, we covered the multinomial distribution and observed the similarities between a binomial distribution and a multinomial distribution. We also gave you an assignment, that is visualization of multinomial distribution. That is all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our last lecture, we covered the multinomial distribution and today we are going to learn the chi-square distribution. So let's get started. So let me just rename the notebook to chi-square. So what is a chi-square distribution or what is the significance of a chi-square distribution? Like the multinomial distribution is used in multinomial scenarios. The logistic distribution is applicable to various machine learning algorithms. In a similar manner, the chi-square distribution is used to verify a hypothesis. So it is used in hypothesis verification. It is more of a statistical concept and we'll discuss it later on when we cover the essential mathematics for machine learning and data science. In that course, we'll be dealing with chi-square distribution. So for now, you need to remember that it has two important parameters. First is df, that means the degree of freedom, and other one is the size or the shape of the returned array. Now let's insert a new cell and let's draw out samples from a chi-square distribution. So draw out a sample for a chi-squared distribution with degree of freedom, because we always need parameters while we extract the samples. So let the degree of freedom be 3 and size be 3 into 3. This is the size which denotes the shape of the returned array. Now from NumPy, import random and x is equal to random dot chi-square, and we'll pass the parameters, that is degree of freedom or df is equal to 3 and size is equal to 3 comma 3. Now let's print x. So this is a 2D array, but all the individual values of this 2D array are samples taken from a chi-square distribution. Now let's move on to the visualization of chi-squared distribution. So let's visualize a chi-square distribution. So we need to write from NumPy import random import matplotlib dot pyplot as PLT, import cbond as SNS. Now we are going to write sns.dispplot and we are going to pass random dot chi-square and within brackets we'll pass the degree of freedom, let it be 1 and the size be, so let the size be 1000. Now we'll specify hist as false because this is also a continuous distribution, so we don't need to visualize the histogram, we just need the KDE part. The KDE part also is not a very precise measure of the PDF, but it helps us to visualize the PDF. So we have visualized chi-square distribution. So it has a longer tail on one side and a very shorter tail on the other side. So in today's lecture, we covered chi-square distribution. We took out some samples from a chi-square distribution and at the end, we visualized a chi-square distribution. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we covered the chi-square distribution and today we are going to cover a Rayleigh distribution. So let's get started. So let me just rename my notebook to Rayleigh distribution or Rayleigh. So first of all, what is a Rayleigh distribution? So Rayleigh distribution is used mainly in signal processing. So the main application of this distribution is in signal processing. We'll discuss it in detail in future lectures. So this lecture is the idea only. We'll not go into mathematical part or complex definitions. Just remember that Rayleigh distribution is used mainly in signal processing. We'll discuss the PDF later on. So it has two important parameters. This is what we need to focus on. The first parameter being the scale. The scale here means the standard deviation, which decides how much the data is dispersed or how flat is the distribution or how flat the distribution will be. And the default value of scale or standard deviation is 1.0. So here scale means standard deviation, which describes the flatness of the distribution and the default value will be 1. And the second important parameter is size. It denotes the shape of the return array. Now let's draw out samples from a Rayleigh distribution. So draw out a sample for a Rayleigh distribution. Now we can have two parameters here. The first being scale and the second being size. So let the scale be 3 and the size be 3 cross 3 as usual. So let's insert a new cell. So from NumPy, import random and x is equal to random dot Rayleigh And let me just pass the scale and the size. Now let's print x to see. So x is a 2D array. It has 9 individual values that are samples taken from a Rayleigh distribution. Now let's move on to the visualization of Rayleigh distribution. So from NumPy, import random, import matplotlib.pyplot as plt, import cborn as sns, and sns.diskplot, pass np dot, sorry, we don't need np here, we just need random dot Rayleigh and pass the value of size, and scale will acquire the default value 1, and we don't need a hist, so specify it as false. So there is a slight error somewhere. Sorry, there's mistake in the spelling of Rayleigh. So make sure you don't spell it incorrectly, otherwise it will give an error and it will take a lot of time to fix it. I'm quite used to errors, so it takes me lesser time, but it will take you a lot of time if you make such errors. Also note that at unit, standard deviation, and 2 degree of freedom or 2 degrees of freedom, a Rayleigh distribution is equal to chi-square distribution. So this is the relation between a Rayleigh distribution and chi-square distribution. So in today's lecture, we covered a Rayleigh distribution. We drew out some samples from a Rayleigh distribution. We visualized it and we tried to understand the similarities between a Rayleigh distribution and a chi-square distribution. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates. And stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we covered Rayleigh distribution, and today we are going to cover our last distribution, that is Pareto distribution. So let's get started. First of all, let me change the name of notebook to Pareto, and let me maximize the screen. So a distribution following Pareto's law is called as Pareto's distribution. So this is the simplest definition, which absolutely makes no sense because it's not much of description. So what you actually need to remember is what is Pareto's law. So don't just write that distribution following Pareto's law is called as Pareto's distribution. You have to mention this 80-20 distribution thing. So what is 80-20 distribution, or what is 80-20 law? Let's figure out, or let's see. So 80-20 distribution or 80-20 law or Pareto's law means that 20% factors can cause 80% outcomes. So this is the important statement, that is 20% factors cause 80% outcomes. And I hope that some of you must have heard of a rule or a proverb or something like this, that is 20% hard work can bring 80% results. So back in school, some of the students used to say that to bring 80% marks, we need to study only 20% syllabus. So that is not true. You have to study 80% syllabus for 80% marks at least. So, but in general, in life in general, you need 20% hard work to get 80% results. So here we have two important parameters. The first being the shape parameter and second being the size of the returned array or the shape of the returned array. Now we'll insert a new cell and we'll try to draw out some samples from a Pareto's distribution. So let's draw out samples from Pareto's distribution. So we need to specify some parameters. So let the shape be 3, that means E is equal to 3, and let the size be 3 cross 3, that means the shape of returned array will be 3 cross 3. It will have 3 rows and 3 columns. So from NumPy import random x is equal to random dot Pareto, and will pass a is equal to 3 and size is equal to 3 comma 3, and will print the value of x. So x is a 3 cross 3 matrix which contains some values that are sampled from a Pareto's distribution. Now let's visualize the distribution. So from NumPy import random import matplotlib.pyplot as plt, import cbon as sns, and sns.distplot, and in brackets random.pareto, and we'll pass a is equal to 2 and size is equal to 1000. And since Pareto's distribution is a discrete distribution, we need KDE as false. So this is how shape of a Pareto's distribution looks like. Hence, we have visualized Pareto's distribution, or we can say that Pareto's distribution has been visualized. So in today's lecture, we covered Pareto's distribution and we visualized the shape of a Pareto's distribution. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our last lecture, we concluded our discussion on distributions, and today we are going to start with universal functions. So let's get started. Let me just rename my notebook first. So let the name be ufunc. So what is a ufunc? So ufunc basically stands for universal functions, or ufuncs in plural means universal functions. So what are these universal functions or U-functs? So these are the NumPy functions that act on or that operate on ND array objects. So these are some predefined functions which can readily be used when we are working with NumPy. And why are they used? They facilitate vectorization and broadcasting, among other important concepts. So U-functs or universal functions are used to implement vectorization. They provide broadcasting and additional methods. So this is basically the reason behind using U-functs or universal functions. So at times we have to perform some basic operations. So U-functs help us perform these operations without explicitly creating a new function. So U-functs can also take additional parameters like where, dtype and out. Now let's try to understand with an example that why do we need a U-func or a universal function. So let's consider that we need to add elements of two lists. So here we have to add elements of two lists and store the result in a new list. So there are two ways to do it, without ufunc and with ufunc. So without ufunc or universal function, we can do it by zip method. Now x is equal to 1, 2, 3, 4, 5 be the first list, and y is equal to 4, 2, 3, 4 and 5 be the second list. Now we need a third list which is or which contains the sum of individual elements of these two lists. So without ufunc we can do it by zip method, and we need to declare an empty list first and then we'll iterate. So for I comma j in zip x comma y z dot append I plus j. Now display z. So there is an error because I have not commented out that portion. So let me just comment it out and run it again. Now you can see that list z contains the sum of individual elements of x and y. So 4 plus 1 5, 2 plus 2 4 and so on. Now NumPy has a universal function to do the same task, that is add. So we can perform the same operation using the ufunc or universal function add. So we just need to write z is equal to np.add x comma y. So sorry, I have not imported NumPy because in earlier example I didn't use. So just let me import NumPy as np and run it again. Now it will not give an error. So the result is same in both the cases, but lines of code in second one are lesser as compared to lines of code in first example. So this is a method of performing sum without iterating over the arrays or the lists, or we can say that without iterating over individual elements. Also, it's worth noting that there are several kinds of universal functions or ufuncs available which help us perform different operations, and we'll discuss all of them one by one in future classes. In today's lecture, I introduced you to the concept of universal functions or ufuncs. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our last lecture, we started our discussion on universal functions, and today we'll learn how to create a universal function. So let's get started. So let me just create a new notebook and rename it. So let the name be creating a ufunc or universal function. Now we'll first learn how to create a universal function or a ufunc, because it may happen that you want to call a function for performing some operation again and again, but it's not available in the NumPy ufunc library, and you want to use it in future programs as well. So you need to create a ufunc and call it in every program you want to call. So to create a ufunc, we need to define a function, and then we need to save it to the NumPy ufunc library using another function. So first we have to create a function, and then we need to add it to the NumPy using another method, that is from py func method. So please try to remember, to create a ufunc, we need to declare and define a function first, then we need to add it to the NumPy ufunc library with the from p func or from py func method. Also note that the from py func method takes some parameters. So from py func method takes the following arguments or parameters. First one being the function or the name of the function. So the first parameter will be the name of the function that you want to add to the NumPy ufunc library. The second parameter is inputs, the number of the inputs that your function will have. And third parameter is the number of outputs. So we have to pass three important arguments, that is the function name, the number of inputs and the number of outputs. Now let's move on to an example. So we'll create our own universal function which will take two arguments, x and y, and it will return x raised to power y as output. Also note that x and y need not to be numbers or integers. They can be an array of integers. So first step is to create a function. So I created a function that is my func, and it takes two arguments, x and y, and I am returning x asterisk asterisk y, which means x raised to power y. And now I'll save this function to the NumPy ufunc library using from py func method. So my func is equal to np dot from pyfunc, and now I'll pass function name, that is my func, the number of inputs, that is 2, and the number of outputs, that's 1, and I'll execute. Let's do one more thing. Let's print the value returned by the function side by side. So let's print my func and let the input be an array. So we have to give two inputs, and that is two arrays. There's an import error because of improper indentation. So let's just correct the indentation. The return is not correctly indented again. So let me just fix it. Now let's run. So 1 raised to power 3 and 2 raised to power 4. So this is the result. Now our function got saved in the NumPy ufunc library, and we can call it in future programs. So in today's lecture, we discussed how to create your own universal function or ufunc. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe, and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our last lecture, we covered how to create a universal function, and today we'll discuss some universal functions related to simple arithmetic operations. So let's get started. Let me just create a new notebook and rename it. So let the name be simple arithmetic. So today we'll discuss some universal functions which help us perform basic mathematical arithmetic operations such as addition, subtraction, division, and multiplication. So we can use arithmetic operators directly between NumPy arrays. So let's first discuss the addition of NumPy arrays. Let me just comment it. So the function add and brackets to pass the parameters sums the content of two arrays and stores the result in a third array or a new array, or we can say that it returns a new array. So for addition, we have the function add. Now let's demonstrate the addition of two lists using the add function. So import NumPy as np, and first of all create two arrays. Let their names be arr1 and arr2. So we already know how to create NumPy arrays. We have discussed it a million times by now. So we have written the code for creating two arrays, and now we'll create a new array which will contain the sum of individual elements of array 1 and array 2. So for that we have to write new array is equal to np.add, and pass the array names. I got an error because of a wrong name. So we got the result as an array which contains sum of individual elements of the two arrays. Now let's move on to subtraction. So we have add function for addition. Similarly, we have the subtract function for subtraction. So the subtract function subtracts two arrays and the result is returned as a new array. So we just need to write new array. Let it be new array 1 is equal to np dot subtract and pass the parameters as arr1 and arr2. Now display, and we got the result as an array of all minus 10s because all of the elements differ by 10 and elements of array 2 are greater than elements of array 1. Now let's move on to multiplication. So for multiplication, we use the multiply function. So multiplication is done and answer is returned as a new array. So the procedure will be same. We'll just need to replace add or subtract by multiply. So new array name is equal to np dot multiply and in brackets we'll pass the parameters. So new array or new array name is equal to np dot multiply and in brackets arr1 and arr2 are passed as arguments. And now we'll display. So this result is wrong because I have to write new arr2. So let me just correct it. So this is probably me figuring it out that what mistake I've done while I was recording the video, but it's the wrong name. So now I corrected it and I got the correct result. At last, we are going to discuss division. So the procedure of division will be the same. We just need to replace multiply by divide this time. So division is performed by use of divide function. Division is done and answer is returned as a new array. So it divides the corresponding array elements and returns the result as a new array. Now let's demonstrate division of two NumPy arrays with help of an example. So new array name or new arr3 is equal to np.divide and we'll pass two arrays, that is arr1 and arr2. Now let's display the result. So new arr3. In my case, I'm using notebook, so it's directly displaying the output, but you need to write print if you want to display the output. Now let's see what if some elements are 0. What will happen? Do we get an error or not? So let's see what happens if we have a 0 entry. So let array 1 be a list containing only 0 and array 2 be a list containing only 2. Now let's divide. So arr 8 or any new array name is equal to np.divide and arr1 comma arr2. Sorry, I have to write comma here, not the divide sign. I'm used to it because in division we use divide sign. So let me just change it, comma. So it gave me the result as 0 because 0 divided by 2 is 0. Now let's see the result of 2 divided by 0. So I'm interchanging. So it gave me divide by error or divide by zero error. So in today's lecture, we discuss some universal functions related to basic mathematical operations. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In today's lecture, we'll continue our discussion on some universal functions to perform simple arithmetic operations. So let's get started. Let me just change the notebook name to Simple Arithmetic Part 2. So first of all, we'll discuss the power function. So the power function rises the value from first array to the power of values of the second array and result is returned in form of a new array. So in our day-to-day life, we need to perform some operations related to squaring, cubing or any x raised to power y. So we can solve such problems with the help of power function. So power function rises the value from first array to the power of values of the second array and result is returned as a new array. Now let's demonstrate the use of power function with the help of an example. So import numpy as np, and first of all we need to create two arrays. So I have created two arrays. Now I'll write new array name is equal to np.power and pass the names of two lists. Now I'll print this new array and the result is the elements of array 1 raised to power the elements of array or list 2. So 1 raised to power 2 is 1, 2 raised to power 2 is 4, 3 raised to power 2 is 9 and so on. And the second problem is how to get the remainder of any division. So to get a remainder of any division, we can use two functions. The first being the mod function and the second being the remainder function. So we can say that both mod and remainder functions are used to return the remainder. And how does it operate? The remainder of values in first array correspond to the value in second. So it will return the remainder of values in first array corresponding to values in second when division is performed. Now let's try to understand through an example. So let's write new array name is equal to np.mod and pass the array names. And let's print this new array. So new arr 1 and it gave us the result. So 1 divided by 2 gives the remainder 1. 2 divided by 2 gives the remainder 0. 3 divided by 2 gives the remainder 1 and 4 divided by 2 gives the remainder 0. So this is how the mod function works. So remainder function is similar. Now let's write new array is equal to np.remainder and pass the array names. So we should get the same result. So let's see. Yes, the result is same in both the cases, demonstrating that both mod function and remainder function are used to return the remainder. Now let's discuss the functions to get the quotient and the mod. So the function div mod returns both the quotient and the mod, and it returns two arrays. The first contains quotient and the second contains mod. So div mod function takes two parameters and it returns two outputs. First one being the quotient and the second one being mod. Now let's demonstrate the use of div mod function. The new array name is equal to np.divmod and we'll pass the array names that are array1 and array2 or arr1 and arr2. Now we have the result as two arrays, the first one being the quotients and the second one being the mod values. Now let's move on to the last topic or last function, which is to get the absolute values. To get the absolute values, we can use two functions. The first one being absolute and the second one being abs. You might have heard of abs function before in some programming language. So we can use abs or absolute, both to fit the job. Now let's demonstrate the use of abs and absolute function. So arr or array name is equal to np.array, and let me pass a list containing some negative elements because we need to get absolute value, which will be same for positive but different for negative. So new array is equal to np.abs and array name. Now I'll print the new array and it gave me positive values. By using absolute also, it will give me the same result. So in today's lecture, we concluded our discussion on universal functions for performing basic mathematical arithmetic operations. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In our previous lecture, we covered some universal functions to perform basic arithmetic operations, and today we are going to cover some universal function which help us to round float or decimal values. So let's get started. Let me change the notebook name to rounding. So in NumPy, there are 5 functions which help us round decimal values. So there are primarily 5 ways of rounding off. They are truncation, fix, rounding, floor, and ceiling. You must be knowing the difference between these 5 methods. These methods are also discussed in AP Mathematics. So let's first discuss the trunc and fix method. So trunc and fix function are used to remove the decimals and return number closest. So it returns the closest number. For example, if it's 2.1, it will return 2, and if it's 2.9, it will return 3. So we can say that the trunc and fix functions are used to return the closest integer number. Now let's demonstrate the use of trunc in fix method. So let's write arr is equal to np.trunc and we'll pass a list containing float values. So it should give us -2 and 3 and the result is as expected. Now let's demonstrate the use of fix function. So I'll write np.fix and I'll pass a list of float values. So I should get the result as -2 and 8. So result is same as expected. So I hope you understand the difference between trunc and fix method. Now let's move forward with rounding and the use of around function. So the around function increments the preceding digit or decimal by 1. So it increments the preceding digit or decimal by 1. If we take an example, if the number is 3.166666, then it should round it to 3.17. Also, we need to pass an additional parameter, that is number of decimal digit that we want to round to. For example, we just want to display 2 digit after decimal or 1 digit or 3 digit or whatever the number of digits that you want after the decimal point. Now I'll demonstrate the use of rounding with around function. So I'll write import numpy as np and new array name is equal to np.around and I'll pass 2 parameters, the number as well as the number of digits after decimal. Let it be 2. So I'll get the result as 3.17. I should get the result as 3.17. Let's see what do we get. So the result is 3.17 as expected. Now let's move on to the floor function and ceiling function. Now it's for you to figure out that what's the difference between floor function and ceiling function, although it will be clear once we see an example. So the floor function rounds off decimal to nearest lower integer. So we'll get the nearest lower integer in this case. So let's demonstrate the use of floor function. So array name is equal to np.floor and we'll pass a list containing decimal values or float values. So we'll display the result and the result is -3 and 3 because these are the nearest lower integer. And lastly, the ceil function or the ceiling function as known in mathematics. So the ceil of 3.166 is 4, but the floor of 3.166 is 3. This is the difference between the floor function and the ceil function. Now let's see an example. So I'm gonna import NumPy as NP. And I'll write ARR is equal to np.field, and I'll pass a list of float or decimal values. So it's giving me as -3 and 4. Sorry, I made a mistake. The seal of 3.166 will be 4 and the floor will also be 4. But it is different for 3.6667. For that value, the seal will be 4, but the floor will be 3.0 or 3. So sorry, made a mistake and I should not execute this block. So I'll just try to undo it. So in today's lecture, we covered different universal functions in NumPy which help us round, decimal or float values. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on NumPy. In today's lecture, we are going to take a look at some universal functions which help us perform logarithmic operations. So let's get started. Let me just change the notebook name to logs. So it's done. So NumPy has functions to perform log at the base 2, 10 and e. So there are direct functions available to perform these logs, that is the base 2, the base 10 and the base e. Log at the base e is also called as natural log. And then we'll discuss a general way to take log at any base. So then there is a general way to take log at any base. First of all, we'll start with log at the base 2. So log at the base 2. So first of all, I'll import NumPy as NP. And I'll write ARR is equal to np.arange 1, 11. It will return me a list of numbers from 1 to 10. So this arange method or function returns array. If you recall, we have discussed it earlier in many lectures. So I'll just print np.log 2 and array name. So it will perform log at the base 2 for all the values in this array. So you can see that log 2 to the base 1 will be 0, log 2 to the base 2 will be 1, and so on. We know that this is log to the base 2 because for 2 it gives us 1, because 2 raised to power 1 is 2. Now log at the base 10. So we just need to replace log 2 by log 10. So np.log 10 and then we have to pass the array name. So it should give us 1 at 10. Yes, the result is as expected because log 10 to the base 10 will be 1. So in this way, we know that our answer is correct. Now, let us take log at the base e. So log to the base e, or popularly known as natural log. So we just need to replace log 10 or log 2 by simply log. And it gives us the log at the base e for every element of the array. Now if you see clearly, it gives around 1 for 3 because the value of e is 2 point something and it's closer to 3. So log 3 base e will be closer to 1. So value of e is 2.718. So log 3 to the base e will give us a value very closer to 1. Now we'll see a general way to perform log at any base. So this is not using NumPy universal function. We'll do it by using function log from math library of Python. So I'll just import from math, import log, import numpy as np, and np log is equal to np dot from pfunc log and 2, 1. And I'll print this np log for 100, 15. So we have created a sort of new universal function. If you see the pattern here, if you don't see the pattern here, compare it with the video where we created a universal function from scratch and stored it in the NumPy ufunc library. So in today's lecture, we covered some universal functions related with logarithmic operations. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates, and stay tuned with us for next lecture. Thank you.